My name is Richard Furrow, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired.
Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GlowCloud team.
Welcome back, everyone. This is Mike Gibbs, and we are here for day 9, or our final day of the Google Professional Cloud Architect Bootcamp. Congratulations, you made it this far. And today is going to be another fun day. What we're going to talk about, we'll begin with a little bit of cloud operations, then we're going to get into some fun things related to security, and then a little bit of billing and support at the end. So we're going to have an event-filled day. If you just joined us and you just found us on the 9th day, which happens all the time, the way YouTube does notifications of people just finding us, that's great. You can go back and watch the previous 9 days of this Google Professional Cloud Architect Bootcamp. My behind-the-scenes team, which is most likely Chris back there right now, will add the link to the chat box for the playlist of the previous 9 days. So you can go back and watch the previous 9 days of this Google Professional Cloud Architect Bootcamp. So please sign up for that, and please see that link, and you can get there. Now, I also want to tell you that our team has created a study guide to really help you pass that Google Professional Cloud Architect certification. My team created it from the materials that I created for this training program. It's about 550 pages. It kind of covers pretty much everything you would need to know for the Google Professional Cloud Architect exam. So, sign up for that. It's completely free. The link will be in the chat box, and it'll be emailed to you. So take care of that. So I hope that's great. If you're just finding this now, maybe share this video with others so you can provide this free Google Professional Cloud Architect training to them. It takes a lot. It costs a lot to put these programs together, but we really feel it's important to go out there and help people with these things. So please share this work. Share it with others to help them in their cloud computing career. Now, just to let everybody know that every Wednesday, I typically come online and answer career questions about building your career, typically 2 to 4 p.m., but typically I mean, it could be other times. So if you want any kind of career guidance or thoughts or questions, you can come online Wednesday. And we also run a weekly webinar where we talk about how to become an architect, where we talk about architect skills, what we do, how to get ahead, how to stand out, and all of it. And it's completely free. You can join us. My team will drop a link to that in the chat box for you as well. And that way you'll have access to those to kind of help and support you in your cloud computing career. Now, at this point, we're going to get back into the content. We have about 45 minutes of content. Again, like I said, it's going to be just a little bit of cloud ops, and then we're going to go into security. And anybody that knows me knows I've loved security, trained so many others for security, and it's something that I'm pretty passionate about. And we can go about as deep as we can in a Google Professional Cloud Architect course. There's other courses on this channel, like the CCSK and the CCSP, which my team will drop the links of, that you can actually find those training as well if you're looking for a little more on cybersecurity. So, Chris, let's get started with this content. Continuing our discussion of cloud operations, let's talk about dashboards. The reason we create a dashboard is and we have a dashboard in cloud monitoring is so we have one place to kind of see what's going on with our organization, and we can take the most important metrics and look and see. Now, we have predefined dashboards that are already natively available in cloud monitoring, and there's no setup or configuration necessary. They're ready to use immediately. Now, if we want different information, for example, we have to create what's called a custom dashboard, and that can be configured using the Cloud Monitoring API. And that offers a lot of flexibility in terms of customization to suit specific needs. Now, if we talk about customization options, we can build custom charts and custom visualizations to analyze, for the most part, whatever metrics we really desire. We can export data for further analysis, or we can keep it in, say, export it to an external tool. We can integrate it with, say, maybe a Grafana, for example, to be able to visualize the data and see what's going on. And we've got a lot of flexibility here. The dashboarding capabilities in cloud monitoring are going to give you the ability to really visualize data very quickly through some form of predefined setup that you make. And that's going to give you the opportunity to really understand what's going on. And you'll have the freedom to create whatever customized dashboards for the most part you need to do. Now, when it comes to keeping systems up, a lot of it is really, resilience. So we have to think about all the flaws we have and what it's really coming down to. So we can't have single points of failure, for example, and there's all kinds of single points of failure, and we have to be able to plan for failures and plan for systems to go down. And there's a lot more that would go into that. That's really not something you would put. That's part of the Google Professional Cloud Architect curriculum, unfortunately, but it's critical to the architect. That's why we have architecture programs that cover all these aspects. But we'll go back to the certification here. It gives us the ability to identify a significant system flaw from these operations perspectives, figure out what that flaw is, and then create a strategy to work around it. And in order to work around any of these things, we've got an incident, then we're going to have to go to the leadership. We're going to potentially have to make a change or a new architecture to go solve these problems. So it's going to take a lot of people working together on this. Now, we always have to think about the business and what's going on, and we're going to have to create some kind of business continuity plans. Now, what does that mean? Business continuity planning is really about determining how you'll keep the business up and operational during and after a crisis. So let's say we have a hospital, and all of a sudden we get a hurricane and the power goes out. How do we keep that hospital up and operational? What kind of systems would we need to power? How would we need to power these systems? Do we need people bringing in fuel, for example, constantly with trucks? Do we need a fuel kind of supply chain? What are the critical applications? What things can we shut down? What things can't we shut down? Do we have to relocate workers? Do we have to create an offsite environment? Those types of things are business continuity planning. By comparison, we have disaster recovery planning, which is more about planning what happens when our systems go down. Now, there's not a lot that really goes into the in the curriculum of the Google Cloud Architect. There is a tremendous amount more in business continuity planning that you can check out in our completely free CCSP program. And again, the security concepts, which we'll get into soon, are going to be very light on the Google Professional Cloud Architect exam. But the Certificate of Cloud Security Professionals, the CCSP, that is the security professional for the cloud, is going to give you a lot more information on cloud security and a lot more information on business continuity planning or disaster recovery planning. So I recommend you go check that out. But the point here is we need to know what's going to happen before the business. We need to know what's going to happen during the outage. We need to be able to plan what goes on after the outage. So there's going to be a lot to that. And like I said, you can check a whole lot of that information in the CCSP program. It is a wonderful intro-level cloud security training program, highly respected certification, and it's free on this YouTube channel. Now, when it comes to resilience, we want to take it from the SRE perspective. We want to look at it first from an SRE perspective, that's site reliability engineering. They're there to try and improve this kind of thing. So we have to think about them being there and people monitoring operations and other people on the operations side. But when it really comes down to it, the way the architecture is designed, the systems that are in place that can tolerate various failures will ultimately determine the real resistance you have and how it's actually architected is going to be the big key to see how your systems are up and operational. Where making sure you don't have those single points of failure. And if you do, how would you mitigate them? Those types of things. But in the end, we're talking about resilience. So let's talk about how we would validate resistance. So, testing alone isn't going to give us a full understanding of how our applications will work in the real world environment. Now, we can do a little bit of that with what's called chaos engineering, which is a discipline from site reliability engineering, where they try to inject faults into various places to simulate scenarios. Now, this is good, depending upon how good they are at injecting faults and how real it is, can give you some information or some not. But these type of chaos engineering is often very good at simulating faults and then figuring out how the systems will actually handle those faults from small to medium disruptions, and should be part of any organization's operations to keep things smoother. The better the architecture is designed, great. And the better as we monitor the architecture and see what's going on, gives us the opportunity to tune the architecture and fix it for the future. So these are the types of things. Now, an organization might try a multi-region environment. And then if they simulate the cloud going down, they realize how fast that would be there. Or where are the ties in the multi-region environment? Where are those weak points? Where are your failure points that you have to make up for? Again, chaos engineering will typically help you with that. So that's why we talk about it. So we've finished the section on cloud operations, and the next section we're going to get to is going to be security. Okay, now we're going to get to the next section in the Google Certified Professional Cloud Architect curriculum, and it's security. Now, we're going to have a lot of fun in this section. I love security, and I'm going to recommend that you see our CCSP training course to learn much more about security. The level of security in the Google Professional Cloud Architect is very light, and security is going to be absolutely critical. And the CCSP training on our website is completely free, and it has a lot of cloud computing, and it has all that you need to know about cloud security. Well, it doesn't have all you would need to know to be an architect, but it will give you tremendous security fundamentals that will not only help you with this exam, but it will help you in your career. So I recommend you see the CCSP training that is completely free on our website as a companion to this. And the link will be in the description of this video. So what is cloud security? So cloud security, we can think of it as about keeping our systems on the cloud secure from harm. And when we think about security, we're typically thinking about the confidentiality, the integrity, and the availability of the resources. So what does that mean? The confidentiality means that people on the outside can't gain information or access to any information on the inside of the system. So it's protected, it's private. It also means that things haven't changed. So, for example, if you're a bank and someone changed their account from $10 to $10 million, that would be lack of data integrity. Or if someone changed the medical chart of a patient, for example, a patient's dose from a normal dose to a lethal dose, that would be a problem. Now, integrity would also be someone putting up a system in the cloud that's not supposed to be there. So confidentiality is keeping things private. Integrity is making sure the things are what they're supposed to be and they don't change. And of course, availability is your system being available for use or ready for use when you want them. And if you're hacked, you're not available. And if you're hacked, your confidentiality is often lost. And if you're hacked, the integrity of your systems goes down. So those are the three goals of security. And like I said, there's so much more security, and I really recommend you go through that CCSP training on our website. It's completely free, and it will really help you with this section because it will go much deeper than Google would ever do. So in Google, security is going to be there natively from everything you do, like it should be part of every environment. And Google's going to give you a great set of tools. And there are an even bigger, more industrial set of tools that you may also choose to use instead of or in addition to Google tools. That's the reality. This is a Google exam, so we're going to prepare you for the Google Professional Cloud Architect things that you need to know. And that's why I said see the CCSP. So services like Cloud IAM and the Cloud Key Management System and Cloud Armor are going to give us some tools that we can use to protect our systems and protect things. So if we think about identity and access management, that's going to be absolutely critical. In the grand scheme of things, we have to determine that people are who they claim to be before they use the system, or and an application is whom they claim to be before they use the system. So IAM always goes back to authentication, authorization, and accounting. Authorization is who are you? But this shouldn't be new to you. You walk into a building in a high security environment and they take a picture of you and they look at your driver's license and they compare you or your professional ID. That's what they're doing. They're authenticating you. Now, the next piece of that is authorization, which is to determine what you're allowed to do and not give you more access than you need to do your job, which is called the principle of least privilege. And then accounting, which is the last component of IAM, is keeping track of what you've done. So Google does provide some very fine-grained controls and permissions through your systems through IAM. And that way you can determine what would be the right level of access for your people. Google Cloud also has multi-factor authentication, which is wonderful because we want to get beyond certain single-factor authentication whenever possible. If we need security, it has federated identity and access management to enable you to federate the Google IAM with the organization's main IAM systems or cloud access security brokers, etc. And that way only authorized users can access the systems. Now, when it also comes to security, we need confidentiality, right? Now, keeping people from breaking into the systems is part of confidentiality, but making sure the information that's stored or in transit can't be viewed by a hacker is also critical. So we talked a lot about encryption. And like I said, there's a lot more about encryption in the CCSP training program, but you're typically dealing with encryption of storage and encryption in flight. So typically when we store things encrypted on the Google Cloud, the default is at rest using AES 256-bit encryption, which is considered enhanced standard high security encryption. And when the data is in movement, it's secured using transparent layer security or TLS type security. Now, sometimes when it comes to encryption, you need heavy key management options. So we can use keys from default. We can use the encryption keys from Google Cloud by default. If we need greater, we can use customer supplied encryption keys, for example, or customer managed encryption keys. And we previously talked about that. So depending upon the level of needs, we'll be able to determine who and how will manage those encryption keys. But we have to adhere to whatever stringent security requirements are needed for our organization. Now, when it comes to security, there's a lot that gets done on the network. So we want to use network security to protect cloud resources and accesses from various things. So we could actually segment traffic in multiple VPCs, for example, if we want. We can create rules to determine what traffic's allowed to leave and enter a VPC, for example. So we've got a lot of components on the networking side and packet filters and things that we can use to protect the network. Nowhere close to what we would ever get in a data center in any cloud, but we've got the best we can do in the cloud. So we can kind of keep that in the back of our mind. Now, when it comes to DDoS protection, most cloud providers have some DDoS service. Google has what they call Cloud Armor, which is a DDoS mitigation service, a traffic filtering, and it can safeguard some applications from attacks and other types of unauthorized components. Now, another component that's going to go into security is going to be security monitoring and threat detection. So we need to be constantly monitoring what's going on. And of course, Google gives us tools for security monitoring and threat detection so we can find things in real time. Now, more realistically, we're going to be taking those logs and we're going to be routing them we talked about a log router to some type of a SIEM system, which is going to be a system that's going to aggregate the logs and potentially uses AI to mine through the logs, finds problems, and potentially can fix them in real time. So that's the reality of what we're probably going to be doing. But understand Google has good tools for monitoring and threat detection. And the Security Command Center will give us a unified dashboard for monitoring security posture, detecting vulnerabilities, and tracking misconfigurations. And then we can use tools like cloud logging and event threat detection to further enhance visibility into these types of security events to give us some rapid response to these threats. Now, let's talk about Cloud IAM. And Cloud IAM is Google's centralized system for managing access to cloud resources. It simplifies role assignments and permissions assignments by having predefined roles like viewer, owner, editor. And of course, we can use custom roles. Now, here's again the reality. So the reality is we're going to typically federate or integrate with the third-party tools such as Okta or Azure AD or any form of Active Directory that we typically leave out there, or any other organization's major IAM tools. So typically keep that in the back of your mind. We're probably going to federate into that. Now let's talk about VPC security controls and what are they? So the VPC security controls are a security feature that's designed to mitigate the risk of data leaving your environment. So they create a security perimeter around what you have. And VPC service controls can help enhance your cloud security by giving you an extra layer of defense that goes beyond the traditional identity and access manager. So what you're doing is you're creating what's called a service perimeter around one of your projects and grouping them into a single security boundary. And only resources inside that perimeter can communicate with each other. So if you really think about what that is, you're basically saying you've got this type of an environment. And everything inside of this VPC service control can talk to each other. So these two can talk. But anything outside of this VPC service control has no access to it. So we don't have the ability by default to communicate back and forth between these two. We have no communication. So what we have is what's called egress control. So we can specify a policy that says, this type of data cannot leave this perimeter. So that means if someone gains access to the resources, they can't send it out. You know, like a data loss prevention tool that's doing egress monitoring. So VPC security controls integrate with a whole lot of other Google services, which means if you can get away with the cloud native tools, it's pretty simple when you're using the IAM policies, the cloud audit logs, and you've got all these tools that are natively integrated with each other. Enterprises typically need bigger, more robust platforms because they're dealing with multiple clouds too. But understand there's a lot of information we get from these things. Now, we have the ability to do pretty much any kind of compliance we would need to with regards to the Google Cloud. They've got certifications for GDPR, HIPAA, SOC 2, ISO 27001. And there's regular audits to ensure that these services meet these strict requirements. Now, understand you won't be able to audit your cloud provider. They won't let you. So what'll happen is companies will do the auditing and produce a report that says it's good. Now, bear in mind, a cloud provider may be paying millions of dollars for someone to audit their systems, to say, yes, they're great. And most likely, if the company that audited their systems after being paid millions of dollars said horrible things about the systems, I don't know if they would be brought in again. So whenever we deal with third-party audits, we always have to think, is there the potential conflict of interest there? I'm not saying there is. I'm not saying there isn't. But we always want to think about that and as we do our planning. So let's talk about some security features that are default and native to Google Cloud. Google Cloud adopts what they call a security by default approach, basically meaning security is part of everything. Data is encrypted when it's stored. It's encrypted when it's in transit. So it's really doing a lot of work to try to protect you automatically. Does that mean you don't have to add security and plan your security? Absolutely not. But they have a lot of built-in security features, such as firewall rules, which you can easily place, which typically come with a default deny all policy. So it reduces your risk of making errors. That does not mean you don't need good security architects and good security engineers. Now, we get a lot of security analytics and reporting. We get lots of Google Analytics tools, so we can take all those features. We can use BigQuery, for example, that great data warehouse that's native to Google, to be able to query and understand what's going on, for example, with our actual security environment. And this way we can do some really advanced analysis of our security logs and help identify things and be able to visualize it with a tool to be able to visualize data in a data warehouse, which is great. And we can get security reports by security tools like the Security Command Center. And that will give us also information that can help us with compliance audits and improve our overall security posture. So there's a lot of good tools here. Now, we really have to think that security is just going to be a critical component in everything we do. So security is about managing risk. And really the focus of security is to understand the assets that an organization has and then create a strategy to protect those assets where that strategy costs less than the assets it's protecting. So for us that are security architects, and if anybody's interested in that, we have a security architect development program that teaches the entire career. I mean, every part of the career. But, whenever we have to think about architecture, it's what are the challenges the organization has? What are their assets? And then what is the right protection strategy? For example, if I'm protecting $1 billion formula for a new drug, that is going to be something that's probably pretty critical. And I'm going to need heavy-duty security for that. But if I'm protecting photos of my cat Cindy, as much as I love my cat Cindy, I'm not going to spend a fortune in protecting that because it's just photos of my cat Cindy. Now, if my cat Cindy was a celebrity and these were proprietary pictures and there were non-fungible tokens about her, then we might protect it because then there would be a different kind of a value. So when we think about security, we have to think about how do we protect that organization, And a security architect like me will say, do we transfer the risk to an insurance company? Maybe. Do we mitigate the risk with, say, a couple of firewalls and our administrative control or whatever else we need to do? Or do we accept the risk because we can't deal with it? So risk management is going to be very critical in the security side. Now, you have to understand that there are trade-offs here. If I make something incredibly secure, the employees may spend a lot more of their time going through security hassles, which will decrease their productivity. If I have a critical security environment and someone spends an hour and a half dealing with our security things each day, of an 8-hour day, and an hour and a half is gone, so now we only have 6 hours and 30 minutes. That's already taking up productivity. So there's always going to be a trade-off between productivity and security, balancing how easy it is for people to do their jobs, our customers to do business with you, for example, versus how secure you can make it. What good is it if you make a website so secure that no one ever wants to deal with the website? So you kind of have to think about that. There's always going to be a level of trade-offs. Now, the cloud introduces a different kind of risk that I want you to think about. Normally, we have the risks of our data center getting attacked. Guess what? In the cloud, we have the same risks of our VPC being attacked. But if you were a hacker, what would you hack? Would you try to hack a single business, or would you try to hack a cloud provider? So you attack the cloud provider and you get everybody's data. So the cloud providers have some of the best DDoS and security infrastructure in the world, and they're also the highest value targets for the hackers in the world for the most part. Like a state government would be, a big cloud provider would be too. So we've got to understand the competitors may want your data, employees may want to sell the data, potentially speaking, or it could be disgruntled and want to harm the company. There's plenty of malicious actors that are going to be there that want to exploit your systems. There's plenty of very good, well-meaning people that accidentally make serious mistakes. So there's a lot of things we need to protect for. So we need to plan for risk mitigation, and there's going to be a lot that we security architects do. And the cloud architects will need to work with those security architects to understand all components of those. So we need to make sure there's a culture of security awareness, that every day we're talking about security with the employees, that we're creating as architects security training programs, that we're thinking about all kinds of security forever and everything we do. So we should be doing that as humans as we walk down the street, scanning around us, making sure it's safe, looking for threats. When you're driving your car, I better not go here. Or there's a soccer ball, for example, or football that just pulled down the street. Let me slow down to make sure there's not a child attached to that ball. So we always want to make sure that we're protecting things and thinking security at all times. And obviously in the cloud, it matters, just like in the data center, it matters. So as these systems evolve in the cloud, And as new systems come out, there'll be new vulnerabilities and new threats, which means the cloud architect and the security architect and the security team really need to keep creating new strategies to protect against the new threats. AI can generate a threat, so we'll need AI to help fight the AI threats. Or whatever the point is, the world's dynamically changing, and we're constantly going to be adapting our environment. Now, we have to be sure we protect our environments. We have to think about how we reduce risk and promote security. Imagine an emergency care system down because it was hacked, or an air traffic control system down because it was hacked. So we have to really think about security and the implications of any kind of problem anywhere along the line. So we have to think about creating the safe type environment. So a lot of people think the cloud is just going to be secure just by using it. No. You have to turn on all the things. Security is a massive practice. It's got many domains. For example, security covers network security, things like access control lists, packet filters, route security, VLANs, VLAN tagging, VLAN trunking, encryption like IPsec, for example, private VLAN, all kinds of things. QoS, that would be things like network security, IDS, IP system, firewalls. But we have application security too, where we have to think about secure code checks, for example, input validation, sanitation, that kind of thing that we would typically be talking about. We might be thinking of other elements of security being data security, things like data classification, data encryption, data loss prevention strategies, for example. So we could be dealing with identity systems, how do we authenticate users? Do we use a username? Do we use multi-factor authentication? Do we use some kind of biometric authentication like a fingerprint or an iris or a retina scan? So it's going to go in IAM. What kind of IAM strategy do we use? Something simple and role-based, context-aware IAM. So that's another domain. So there's a lot of domains into security. And not only risk management would be another domain. So there's a lot that goes into security. And that's why I recommend seeing that CCSP. It's going to give you a lot of understanding of security, which will not only help you reason out questions on this exam, it'll make you better. So please see that CCSP training. But understand that security spans governance and risk management, compliance, policy, operations, disaster recovery, legal, marketing. It's the entire organization. It's not just the technical people. We need engineers and security engineers, but we need more than that. We need the leadership involved. We need people with a wide variety of skill sets because, this is a policy environment. We have to create the policy as architects. That's what we do. The incident response procedures, which we do as architects, the business continuity planning, the disaster recovery plan, and security is everyone's responsibility because all it takes is one person to do the wrong thing and it can compromise the organization's security. So this is way beyond this exam. Please understand what goes into risk management, things like identifying an asset and identifying the risk of the asset being compromised and how frequently you think that asset could be compromised. So like I said, see the CCSP. So I'm going to go back to that CIA triad because anytime anybody talks about cybersecurity fundamentals, that's what we talked about. Now, I talked about confidentiality, meaning the information's protected. And I talked about integrity, meaning the systems haven't changed and the availability of the systems being up. But really, let's think about this. So, and we can talk about some things that are necessary. We'll all whiteboard it as we go through this. So let's say what we have, let's say we're just talking about data right now, and realistically speaking, the entire system. And I want you to see how it goes into many, many things. So if anyone has access to the systems, they can potentially try to get the data. So if we firewall this off, for example, let's say out here is the internet. And the internet's a scary place, so the internet tries to go to the firewall. That data is still confidential. It hasn't left. Now, if we implement, you heard me talk about it before, if we implement some form of data loss prevention on the way to the internet, some kind of a little DLP strategy here, what that can do is If somebody tries to take anything out of the network, for example, or out of our environment, on the way to the internet, this DLP system says, no way, you're not allowed. Now, not all data needs the same level of security, so we need to classify the data to some degree. So let's say we might have just basic data, and then we have sensitive data, and then we have top secret, or something like that. Now, each one of these types of data is going to need different levels of protection. So what we typically want to do is categorize our data and then find a protection strategy for each type of these data, for example. But also confidentiality. Let's say now a hacker were to bypass the firewall and every other security measure and IAM we actually had, and then they got access to the storage. Well, if they don't have the decryption key, they won't be able to see what's actually in the encrypted storage. So again, that's why we encrypt data. Now, if you notice when we encrypt data, we also get something called a hash, typically speaking. And what the hash is it's a mathematical calculation that shows that your data hasn't been changed. And I go into very detailed information on hashing inside of this CCSP program, which is one of the reasons I'm strongly suggesting that everybody get there. And that way you can see the things that go into it. But this is just an example of confidentiality. No, it took network security. It took data loss security. It took other tools. It took IAM, and all these things go across domains. So confidentiality is not being able to see. And encryption is going to be our main tool for confidentiality, because if I take something and I turn it into gibberish or something that's worthless or scrambled without the decryption key, it protects our environment. So we're going to use encryption as much as we possibly can. Protect these things. Now, we have to think about protecting the organization's intellectual property, sensitive customer data, and any kind of things that's being used to keep our system safe. Now, integrity, when we come down to it, means nothing's changed along the way. And that's typically done via hashing. The way hashing works, and I always thought hashing is the coolest thing, is as follows. Let's say we have the letter A. If we put the letter A into a 256-bit hash, into a hash, let's say this is a hashing algorithm, and we stick that input in, and we always get the same identical 256-bit output each time. So I have no idea if that's 256, but let's just pretend it is for a second. If the letter A always comes out as this, we can verify the hash that if this is what the data had and this was the hash initially, and it still has that hash, the data hasn't changed. Now, the way this works, which I always thought was cool, is we could take the letter A and we can put it into a hashing algorithm, and every time we get the same output, but it's a one-way hash. And what does that mean? Which is why I always thought it was cool. Nobody can ever go from this hash, for the most part, back to the actual data. So it's one way. So we use hashing to make sure our data hasn't changed. Now, we use hashing everywhere in encryption. If we use IPsec, it has hashing. If we're storing our data, it has hashing. Now, the key to remember with this hashing concept is if the letter A comes out as 256, that is a big chunk of data. So in many cases, the hash is going to be much smaller than the actual data that we have, but that's how hashing works. So the hash, if it's not the same, means the data has been compromised. Don't use it. So if you really think about it, if you open a new container of anything, let's say you've got some Tylenol, for example, and you wanted to open the Tylenol, but you bought it from the store and the seal was broken, you'd be kind of concerned about that, right? So realistically speaking, these are the things we're typically talking about. So I hope that makes sense. That's why we're checking these hashes. Or if you bought a soda and it was already opened, you probably wouldn't drink it. Now, availability is just the systems being up there, and the primary driver of availability is going to be how much redundancy you have in the actual system. How well did you mitigate single points of failure, or do you have none? What are your change control procedures like? What are your processes like? But if you get hacked, your systems are also not there. So let's think about the kind of hacks that would bring our systems down. A distributed denial of service attack, for example, where someone sends a tremendous amount of data to us to overwhelm our systems. So that could be an attack from someone coming on the network. Now, what if our network design is bad? Meaning we got a bad routing because somebody didn't understand IP addressing. They have too many routes in the routing tables. The routers crash. We're still not going to have an availability system. Or let's say we've got two links to connect us to the cloud are on the same provider, and the provider goes down. We're still going to be down. So it takes a lot into designing for high availability and basically no single points of failure. And I want to show you what I actually mean by no single points of failure. So let's whiteboard out an environment of just the networking to get to the building and even to the cloud. So let's say I needed at any one point 40 gigs of traffic going to the cloud provider. And here's my building where my users are that want to receive everything on network. So let me just call this my campus. Now, I want you to think about the situations of what could happen. And I just want you to realistically get an idea of what high availability really looks like. So we're going to create a little switch router along the way to connect to the cloud provider. And I want you to really think about how much resiliency is going to go in here. So let's say this is the device that connects us to the cloud provider. So I want you to think about how carefully this is. So let's say this device has 4 links, 4 10 gig links to the cloud because it always needs 40 gigs. So we've got 10 gig times 4 in a link aggregation group. So that means we've got 40 gigs on this router. Now, the reason I'm showing this is I want you to think about the router. Now, imagine this router itself, because it needs power, was plugged into a single power outlet, or where it's power distribution unit. And what happens if the circuit breaker to this router were to blow? That's on the PDU. So all of a sudden, the power is plugged into here, and the circuit breaker on the power distribution unit, which is sitting in the rack, goes. Guess what? All these connections to the cloud are gone because we don't have a device. So typically in a high availability device, and let me just, maybe I need a little more space. Oops, the wrong way. So typically in a high availability environment, that router will have 2 power supplies. And why will it? And each power supply will be connected to a different power distribution unit. On a different circuit breaker inside of the building because we can't have the power failing. Now, what we might also do is in a high availability router, they typically have something called the control module, which is the brain of it. We don't want this thing going down, so we might put 2 brains in it so that in the event that the first brain dies, we've got a second one. Now, what we probably do is when we put these cables along the link, we're probably not going to put them all on the same card along the way. So let's say this port can support 100 gigs. We're probably going to split these lines across multiple ports. And by doing so, multiple cards, we can lose a card, we can lose a control module, we can use power. Now, the next thing we're going to have to do is we can't have a single router connecting us to the cloud, for example, because what if the router were to die, or what if the provider that we're using were to die? Well, in that situation, this would be bad. So let's say if this was AT&T, then the bottom link might be on the bottom set of links might be on Verizon. Just remove these power connections because it's good at this point. I think everybody got the point. So the bottom link would have to be on another provider, say Verizon. Now, if you think the connections to this cloud, we have to be also very careful. And I'm just showing you just the campus connecting to the cloud. So what happens if the connections coming in from AT&T and Verizon are sitting in the same underground conduit? Now, for example, if these links are all coming through the same underground conduit, which is coming into the building, and somebody cuts this conduit, guess what happens? We lose both AT&T and Verizon. So we're going to have to make sure that the second service provider we use coming into that building that's going to connect us to the cloud is going to be in a different size conduit in a different part of the building in case a backhoe were to break this. So as you can see, this is just the connections to the cloud, let alone what the routing and use is going to be on the campus, let alone what we have. But that's what it takes to get to a level of resiliency that's going to give us high availability. No single points of failure anywhere. So that's really what we need to think about when it goes into availability is no single points of failure ever. But if our systems are hacked, they're down. So when we talk about security, let's talk about these three kinds of controls: administrative controls, technical controls, and physical controls. And all of these are important. So at the security architect level, we're typically creating administrative controls where we start. Now, administrative controls are like a policy, a procedure, or a guideline that people follow. So we security architects, we cloud architects, we're always working with the executive team, but we security architects specifically in these kind of things are working to create that organization security policy, which comes from the executives, which is basically how the employees need to do their job, the rules they need to follow, step-by-step procedures on how to do things, guidelines on best practices, those kinds of things that people are going to be given. And in the administrative controls, we will document our security practices, we will document our security awareness training programs, and we will run security awareness training programs. We will come up with incident response procedures, security principles, and best practices, for example. Now, we will also implement technical controls. Our technical controls are going to be technology that's going to block people from doing things. So, for example, we might use a firewall to keep unwanted traffic from hitting our network. We might use identity and access management to determine if you're allowed on the systems and what you're allowed to do. We might, on the network itself, put packet filters or not allow the routers to even have the routes to certain environments to make sure you can't get there. We could putting host-based firewalls, host-based IDS systems, anti-malware systems on the end hosts, and any other kinds of things we do in our environment. Now, physical controls are also going to be important. Imagine if I let you just plug into the router that connected to the cloud or the switch. Well, poof, you'd have access to the cloud. This could be a problem. So I might want to use fences, badges to enter facilities, guards, dogs, barriers. So lots of environments. So physical security is going to be pretty incredibly important. So if you really think about those three things, it kind of goes over the levels of security. So now if we talk about controls, we typically have preventative controls, detective controls, and corrective controls. And we'll talk about what they actually are. A preventative control prevents things from happening that we don't want to happen. It prevents. So a strong IAM policy prevents unauthorized access, for example. Firewalls tend to prevent you from doing something you're not supposed to be able to because you won't be able to reach it. Data security controls protect sensitive data. So preventative controls try to prevent security threats from actually turning into a real incident, to reduce your exposure, reduce your attack surface, if you will. And they're typically designed by the security architecture team and the policy teams, and they'll be implemented by the engineers. Now, if preventative controls prevent, we have to be able to detect things when they happen. And this is called detective controls. And detective controls, by definition, are designed to help identify unwanted activity that's actually occurring or already has occurred. So the security operations teams are starting to notice something that they've got some indicators of compromise. We may have some automated detection systems that flag suspicious activities or anomalies like a SIEM system. We might be detecting malware, for example, through our systems. And when we look for things, we're looking for any kind of artifact or data point that's going to suggest that a user or a machine has been compromised. And often we see privileged permissions where someone gains access to a system and escalates their permissions somehow to a way they can do damage to the system. So that brings us into corrective controls. Now, corrective controls are things that are going to help fix things. They're actions we take to remediate unauthorized activity or resolve threats. For example, we might patch a virtual machine to fix the security vulnerabilities in its code after we detect it, or an incident response action to handle, okay, we're hacked, now who's going to do what? Now that we're hacked, who's going to stop the attack, contain it, how we're going to recover from the attack, who speaks to the press, who speaks to regulators, all that kind of stuff is something that we typically have to plan as architects, incident response plans and procedures. And, if a system was damaged, how do we roll it back to a good configuration state, or do we rebuild the server, period? So there are more your corrective controls, and that's to restore the system and get things back to being operational. Now, what is really risk? Risk is really calculated by the asset times the threat times the vulnerability. So if we've got $1 million asset and a 10% risk of it being lost, for example, then we'd have 100 million out of, if we have $1 million asset and a 10% risk of being compromised, then our risk is about $100,000 per year. So we have to be able to calculate risk at the security architect level. And risk is really the likelihood of something occurring and the impact if it were to occur at the time. So when we understand what our risks are, and like I said, we have a lot of great risk calculations in the CCSP. We divide a whole chapter, probably 2 hours to calculate, maybe an hour or more calculating risk, so I recommend it. But we have to build a plan to deal with risk. That's all it is. All security is how do we mitigate risk? So we compare the assets, we compare the threats, we compare the vulnerabilities, and we combine them. So if we typically think about the traditional security module that we always have had, we typically have security architecture teams and infrastructure architecture teams and data security teams and application security teams, and I'm not joking, security operations teams, risk management teams, and compliance teams. They're all separate teams. Now, if we think about that, that can be a bit challenging. We've got to get these teams working together. So if we really think about having a team where we've got one team that's got another team, and it's almost like we've got little gates and checkpoints between teams, it's going to take a long time to find security problems. So we've got this kind of thing. Now, some security teams probably are so far away from the business that they don't even understand the context of the applications or how the applications will be used, which now means we're going to have a lot of overloaded people, because if we don't know how to design it right, the operations team is going to be overwhelmed with incidents. So we have to think about how do we tie these pieces together, get people talking. And that's really why cloud architects and security architects even exist. There are all these teams that do all these things in the organization, and they're very good at what they do, and they're filled with smart people. And we're there to kind of break down these barriers and work across each of those teams. And that's why architects don't touch the technology or configure it. They're busy working across these various teams to be able to bridge this business unit, this business unit, this business unit, this security need, that security need across the entire environment. So we're on the cloud, things are going to change a little bit. We're going to have what's called the shared responsibility model. And what does it really mean? It means the cloud provider manages their stuff and you manage your stuff. So keep that in the back of your mind. And we talked about the type of service model. For example, in a SaaS environment, pretty much you manage everything except for the underlying infrastructure. And in the software as a service type environment where you're using a third party and they're hosting the application and even hosting your data, you don't have a lot of control. You have things like IAM. So kind of keep in mind of where the environment is, what you have, and also understand that some things will be out of your control based upon the service type you choose. And then you're going to have to know what's in your control, what's out of your control, and be able to say, can I allow someone to take this control from me, or do I need to control this? Now, understand that we can set up controls which can help, the provider can help manage, like the preventative controls to prevent things to happen, like a firewall, a detective control to basically scan something that's going on, like a SIEM system, and a corrective control, which is go fix it. So when we think about the cloud computing environment, we think of this pretty much the entire network and data center. So anybody that's working on these systems is responsible for security. The people that are developing the applications are responsible for making sure these applications are secure. And they don't allow things like cross-site scripting, and they don't allow you to put in bad things to make the server do bad things, for example. It's everyone. So if we think about various things and DevOps, for example, DevOps is doing a lot of automation, which basically makes things fast, which is great. But if we're doing things fast, we need to make sure that security is also being checked at the code level all along the way. So that brings us into DevSecOps, which is basically DevOps that's also doing some security things, more of the application security, not entire security, but the security of the development environment, and security is integrated into everything that's done as they speed up workflows, which is terrific. So we obviously need dedicated security teams in any real environment that we're dealing with, because no matter how much automation we do, there is still a lot of threats out there, and we will need to make sure we've got a team of dedicated people with a dedicated skill set and the time and ability to focus on security as their main job. Now, when we think about these kind of teams, we need to have some people that are focusing on automation, for example, and innovation. We need other people that are focused on optimizing the business and mitigating risk. And we need other people that are going to be focused on managing these things and working with these systems all day long. So, we might talk about the modern cloud security model as integrating automation into everything we do, and automation into security, and we should. No, we understand that security is everyone's model. So we have to make sure that everybody's here. And, we have this built-in security of the cloud. And by built-in means if we turn it on and we use the features, we have inherent security. But that may not be enough for some businesses. They may need more industrial tools. And we should always be in that environment. So let's think about the collective responsibility. There needs to be some collaboration between the cloud provider, for example, as well as, say, the customer. We need to make sure that the systems are designed based upon what needs to occur. The appropriate controls are actually put in place. Okay, we are back and we are here to answer any questions. As you know, and I'm not going to speculate as to why, because we don't really know why yet, there are some global internet things that are going on right now. Some of it looks like it's occurring on Google Cloud. Some of it is not. Some of it is occurring in China Telecom and other parts of the world. So what you can see is, if you're ever curious to at least start to monitor these things, Cisco has a place called Thousand Eyes, where they, for the most part, they monitor what's going on with key routers on the internet, that type of thing. And you can see that there's something going on in China. And if you notice, it's China Telecom, because if you look at their autonomous system, all these outages are across China Telecom. There's also something going on, which looks like in Singapore, as it pertains to Citibank. But if you look across the US right now, you see a couple of things. You see, this one is Spotify, which is hosted on Microsoft. But this is actually Spotify that's also on Microsoft. Now, over this Spotify is on Microsoft, but if you look a little closer, this is on Cogent Communications. So they're struggling on both. So it's too early to speculate. Is this an event from a global hacking thing? Are there some wide area network service providers that are having some issues in their network and it's a BGP pairing point? Or is it just a Google Cloud thing? But this, just so you understand, is the reason why organizations typically, and I'll put that link in the center, typically would never only have a wide area network from AT&T. It would be an AT&T or a Verizon or a Vodafone and a BT. It's always two. This is the reason why 98% of organizations don't use a single cloud, that they leverage multiple clouds, multiple data centers, because they need high availability, because they don't want their systems to be down. We may do a live discussion if we know more about this and we get real answers to what's going on. I'm always happy to have a multi-cloud architecture discussion if you want, and talk about why things are multi-cloud and what goes into multi-cloud. If you want that, I'm sure we can set up a 2-hour live stream that we can do and use. Just let me know. To keep that in the back of your mind. That is Thousand Eyes. That is run by Cisco. I'll drop it in the chat box for all of you to see. Now, there are a couple of really great questions that popped in, and I want to make sure we answer that, and then we'll get into more content. Bear with me. My team is looking. They'll bring in the first question in a second. If not, I'll just find a way to read it. So the first question that I saw that popped in, and it's actually a pretty interesting question, and I'm happy to address it, is from Mustafa Muhammad. And he said, hello, stumbled onto your channel, finding it very useful. Your main question is, how can you be consistent when you're learning while you're all over the where? So this is a really great question, Mustafa, and I want to kind of give you my perspective on it. So it's not easy to really go through something that's big and something that's challenging. And I did it a few times. I did it when I learned how to practice internal medicine as a nurse practitioner in my youth, and I did it when I transitioned careers. And one of the things that I always used as a motivation was, I don't like where I'm at. And if I have an obstacle in my way, I want to do anything I can to get past that obstacle, because a challenge is not really a challenge. A challenge is an opportunity. And of all the people, Mustafa, that I've worked with across the world, the people that are the most successful realize every time they've got something in front of them, that challenge is an opportunity to create a business, an opportunity to create a product, or an opportunity for you to do what no one else will do. So I'll tell you what I did. When I was working in healthcare, and I've taken people and gotten them hired at every company you can imagine: Apple, Amazon, Cisco, Google, IBM, Accenture, Deloitte, KPMG, Capgemini, PricewaterhouseCoopers, in almost every country in the world. What I typically look at is I say, what is it exactly you want to do? And if you wanted to come into one of our webinars, we can have a live conversation on Zoom, and my team will give you a link to that. But I want you to find out exactly what you want to do. And I want you to find why you want to do it. So when it came to learning networking, I can tell you my motivation was I had a family in Greece. I couldn't afford to talk to them because it was $4.25 a minute or $250 an hour. And I'm not joking. And I just couldn't afford it. And all of a sudden I saw the internet and said, I have to be in this networking thing. It didn't matter that I had a several $100,000 master's degree that I had already done. It didn't matter that I had a previous career. I just loved this networking thing. And I put everything I had into it. And I'm literally speaking, I read all day, every day. I worked my job from, say, 7 to 5, and then I got home from 5 o'clock till midnight. And I just did it until I got to my goals. And I got to tell you, here's what happened. Within about 6 months, I was hired as a lead engineer. And within 3 months after that, I was hired as a lead architect. Within 2 years, I was working as a principal architect at one of the larger technology vendors in networking. And the key was the following few things, is to find exactly what you want and then zero in on exactly what it's going to be. And there's a reason I say zero in. So I see you've listed networking, cloud, DevOps, cybersecurity, governance, and compliance. All your interests, great, but you got to pick one. Now, if you were to go to Cisco, you would notice that they have multiple Cisco certified internet network certifications. And I'm going to tell you that the CCIE is the hardest exam in the world and one of the first few people in the world to actually pass it. And it was miserable. It takes the average person a couple of years to do it. $20,000, $30,000 of study materials to pass this test. It is a miserable test. But you know what? They have one for routing and switching. They have a different one for wireless technologies. They have a different one for voice technologies. They have a different one for security. And that's just a start. And even at Cisco, a networking company, they had a half a dozen different specialties that people would spend their entire life picking. So what we need to do is find out what you want to do. If it's networking, do you want to be a network architect? That's one set of skills. Network engineer, completely different set of skills. Cloud architect, great set of skills. Cloud engineer, completely different set of skills. Cybersecurity as an architect, one set of skills. As a cloud security architect, slightly different set of skills. As a security engineer, completely different skills. And that's going to be the key. So you basically speaking, you need to figure out what you want, what you're passionate about, why you want to do it. And then you need to build a plan. And then you do one step, the next step, the next step. And if you've got a coach or a mentor along the way, it'll get you there. And that's why we train people the way we do. But if you want to come to one of our webinars, I'd love to talk to you. I'd like to see what you like, ask you some quick questions, see what you're good at, and see what you would need training at or what you don't need training at, and make recommendations. Chris from my team, please invite Mustafa to a How to Become an Architect webinar, and I'll just use that as an opportunity to ask the right questions and then be able to help him get to his goals. Thank you for the question. It's a wonderful question. Is there anything else back there, Chris? It's hard for me to tell. Do you have any other questions you'd like me to answer before we go back to this content? Because I am more than happy to. Just let me know how I can help you. And while I wait to see if there's any questions, if you just joined us, maybe give the video a like, maybe subscribe to our channel, for example. And if for some reason you just found out about this in the middle of this on the 9th day of our Google Professional Cloud Architect Bootcamp, please note that there's a playlist of the previous 8 days. You can watch it at any time. Please note that there's a completely free study guide. It's about 550 pages. Our team wrote it to help you pass the Google Professional Cloud Architect exam. It's all free. Sign up. It'll be emailed to you in about 15 minutes. Within 15 minutes. And if you're curious about how to become a cloud architect, my team will drop a guide that'll tell you all the skills and all those fun things we need. And you can join me in an architecture webinar. We run every week. I didn't see any more questions come in. So hopefully maybe give me a hashtag Google Professional Cloud Architect so I know you're awake, alert, and oriented. And then, Chris, let's go with the next session. Continuing our discussion of security, we're going to start talking about compliance and the roles of security engineers and risk managers. So most engineers look at compliance as restrictive and cumbersome, which in many cases it is. The risk managers in an organization are going to say this is absolutely critical for making sure we stay legal, we mitigate fines, we mitigate punishments and any kind of legal consequences. So we typically have risk management involved, and, risk management may have attorneys involved. It may have other really good scientific people like actuaries that are great at calculating risk, for example, and managing risk. But most organizations will have risk managers, and the architects are going to have to work very closely with those risk managers. I worked closely with many type of attorneys and other risk managers throughout my life. So risk managers are going to need to understand risks for real, far beyond compliance requirements. They're going to understand the laws. They're going to understand the regulations. They're going to understand the industries. They're going to understand the penalties, what needs to happen. And this is an area of expertise. So we as architects need to be very thankful of these of the risk management people. And it may feel like they're trying to slam the brakes on what we're trying to do, but they're trying to keep us legal. So we need to work very closely with that. And, from the engineering perspective, I've been there myself in my youth. If we really think about it, it feels like it's in the way, but it's keeping us legal, which means everybody gets to keep their jobs. Now, understand we can never get the risk to zero. Our point is reducing risk and getting it to an acceptable level. So when we think about risk and mitigating it, a lot of it is going to come from our design. And we may need to explain our design to the to the people that are in the compliance department so they can understand its impact on regulation. So we need to be able to prove that our systems meet certain needs by being able to show the architecture is actually compliant. Now, if we manage our systems, there's a certain set of things we do, but if we're dealing with a cloud provider, they basically have various compliance things there, and their systems have already been done to theoretically support them. And of course, an independent third party will typically come in and say, yes, you meet all these requirements. So one of the compliance things we need to think about is PCI DSS, which is the Payment Card Industry and Data Security Standard. Now, anytime we're dealing with an organization that basically processes credit card transactions, for example, they need to be compliant with PCI DSS. So one of the ways PCI DSS makes us to think about is, how do we protect sensitive data? So for example, you may not show all sensitive data, or you may replace it with what's called a token or token sensitization or non-sensitive tokens. So you have something that's sensitive, you replace it with something non-sensitive, and you can't go back from the non-sensitive to the sensitive. That's really what we call tokenization. Now, there's other ways we can actually reduce data. We can do data hiding. For example, you may log into your account and you may only notice the last 4 digits of your credit card number, not the previous 12 digits. That's ways to hide data as well to protect your data. So tokenization is a mechanism that they talk about to keep your system safe. And there's many more in that CCSP training. So we really want to keep this mindset that a breach is inevitable and potentially that we're always breached. So we need to get our mindset to the point that people are always trying to attack us. And at some point, they're going to get in. So we want to make sure is first, how hard can we make it to get in? And how do we mitigate it as fast as possible? So if we really think about it, when it comes to security architecture, let's say we've got an asset that we're trying to protect. We need to make it cost and feasible for someone that's willing to do it. So if we've got a $1 billion asset, we want enough security that it's going to cost more than $1 million to get to, or if we got $1 billion asset, we want to make sure it costs more than $1 billion to break in. And that way we're protecting the asset, because the people that can break in under really high security circumstances can do it with enough computing power and resources. But we want to make it infeasible for them to even want to do it. If it costs more to get it than the value of what you're getting, most criminals don't attack that system. So we always want to think about that. So when we can remove sensitive data, we remove sensitive data. When we can delete data that we don't need, we remove it. If sensitive data is in a database and that database is breached, we've got a problem. But if it's not there, we don't even have to think about the impact of it anymore. So the next compliance thing we need to talk about is GDPR. And there is a lot of compliance under GDPR. Like I said, see the CCSP or read the entire GDPR, or both if that is applicable to you, meaning you're working with systems in Europe, or you're dealing with European Union member citizens, even in a global business, which is for the most part, most people in today's world in a global business. So the key here is users have to consent. So with GDPR, you can't just keep customer data without their consent. And organizations must keep the minimum amount of data they need and only what's necessary. And some of the things we're talking about is the right to erase data. For example, a user has the right to have their data erased. They call it the right to be forgotten. So if we've got a U.S. organization that operates in the EU, they have to be GDPR compliant. Now, there is also data restrictions for the most part. So for the most part, if you're dealing in Europe, you can't store that information in the United States. It has to stay in Europe. No, there are workarounds to this. And like I said, this is heavy regulation. So either read it or see the CCSP course, because there's a lot more that's going to go into this and far beyond the Google Professional Cloud Architect exam. Now, we also have the COPA or the CCPA or the California Consumer Privacy Act. Now, that's for people, a California state law, and it's going to be very similar to GDPR, and it's going to require organizations to protect personal information of California residents. And that means any company that deals business in California has got a new set of rules and regulations they have to comply to. Now, let's talk about legal consequences. Non-compliance is considered a criminal violation, not just a financial penalty. So executives potentially face jail time if they knowingly fail to protect sensitive data or ignore compliance rules. So we always have to think about this. So let's think about data protection and accountability. we have to do a good job protecting people's data because we're accountable for it. So if we really think about it, we start thinking about the CIO or the CISO. They're responsible for these systems to a degree. And that means they could be penalized if they don't go down the wrong path. So keep that in the back of your mind. Now, when it comes to security, identity and access management is going to play a big role. So it's going to manage user authentication and the such. So when it comes to cloud identity, it's going to integrate with LDAP or Active Directory, which for the most part means you can integrate into most systems or federate. It can provide single sign-on and integrate with third-party providers. Let's face it, it would be infeasible to manage 3 different kinds of IAM systems. But if you've got users on AWS, Azure, and Google, and you either use a cloud access security broker or they all federate with your own directory, then everything can use that same directory for authentication, what have you. So let's talk about some best practices, at least for the purposes of the Google Professional Cloud Architect exam for user authentication. If you're using fully managed Google accounts that are tied to your corporate domain, it will help. If we think about single sign-on and directory synchronization, that will help simplify the end user experience. So where did this come about? In the old days, what would happen is we would use a different login and password to 50 different systems, which the reality is was more secure. And here's the reason it was more secure. If you got access to only one password, then you could only access one part of the system. Here's why that became less secure. Because it became so hard for users to remember how to log into 50 different systems and their usernames and passwords that they would put sticky notes on their desk with their usernames and passwords, which violated all the security the company put in, ending up hurting security. So we want to make sure that we use single sign-on when it makes sense. Now, we want to use reputable, real, large-scale identity management solutions. So think of things from like Okta to enhance your security and really streamline IAM. Now, when it comes for user authentication, at the bare minimum, we should use a strong password policy. We really don't want to use passwords unless we have to. We want to use some type of two-type verification minimum. So whether that be it's a hardware or software token, but we want to use some type of multi-factor authentication or two-step verification or something. We want to take any unmanaged accounts that we have and find a way to manage them and ensure they're properly managed through cloud identity. So we don't want anybody accessing anything without our permission and knowing who's allowed to access. Now, we also have resource management security. And remember we talked about the Google Cloud Resource Manager? And that provides resource containers like organizations, folders, and projects to help group and organize your Google resources and how they simplify billing, governance, and overall organization management. Well, it also can assist us with security. We can automate project creation and naming, and that way we'll create things consistently using a consistent naming convention so we can figure things out quicker. We can use many projects with a folder hierarchy, and by doing so and organizing on a folder hierarchy, it can help us separate and organize projects in a way that's going to mirror the organization structure. So we might think about how we would manage resources. So we might want to do some kind of billing management and labels. And we want to consider how the organization will manage billing across various teams. And we want to leverage some form of a label to help govern the organization, manage its cost effectively, and provide clarity in billing reports. If we label our systems, we know what's being used and where they're coming from, what have you. So we want to use an organizational policy structure to set and enforce restrictions at different layers of the resource hierarchy, ensuring better control of resources. Remember, we talked about apply it to one level and other levels can inherit it. Now, we want to talk about Cloud Identity and Access Management, Cloud IAM, and that's going to manage the policies and basically give us our privileges or what we're allowed to use. And we can use role-based access control here, which for the most part is like what we do is we create a job function, for example, a manager. Then we give permissions to the manager. And then after that, all managers that we had, every time we hire a manager, they're part of the manager group, and then everybody gets access. All managers get access to the same things. That's role-based. Now, we could also use attribute control, which gives us more things. So now we're not just checking on the same user. We can begin looking at the device or the time of day or other things. We're getting much more information. And then we could get into context aware, where we can check if it's the device, if it's the right time, and we can even use AI systems to grant access or even deny access or send additional challenges to check security. So there's a lot into context aware I am. Like I said, check the CCSP training out on our YouTube channel. It will help you dramatically with not only this exam, but your security knowledge, which will be very valuable as an architect. So some best practices with IAM: don't give people more access than they need to do their job. Ensure the principle of least privilege. Ensure the separation of duties. Don't give any one person the power to do too many things inside of your organization. Just don't do it. Imagine you have something that's critical, like a safety deposit box. You and another person typically have to turn the key in order to get in there, like a manager and you. So that's separation of duties, and that way no one person could have access to everything. We want to avoid any kind of direct permissions assignment. So whenever possible, don't create a single user and just apply permissions to them. Assign roles or something that we can manage it and scale. So when we deal with one system attaching to another system, we want to use service accounts. So we want to leverage groups and service accounts any way we can to delegate responsibilities efficiently. We don't want to download the service account keys. So we want to use short-lived credentials for security. We don't want to download our secret keys. So if you have to download your keys, use a key management solution like a HashiCorp Vault or a cloud or any type of hardware management solution. So protect your application's secret keys. Use some form of key management software like Google Secrets Manager to protect, rotate, and revoke and manage your secret keys securely. From a networking perspective, network security is one of your biggest. It can protect one subnet from talking to another subnet, protect system traffic from getting into one system, determine who could talk to whom. So we have a tremendous amount of security things we're doing on the networking. Even a little mini mistake on the network can lead to compromise. So we want to typically use firewalls anytime we have a perimeter to our network. And we have other options that we want to think about. So typically think about firewalls and filtering patterns and not letting anything in. And if we need to place something available for use to splice someone else outside of our systems, use a demilitarized zone. Now, whenever possible, we want to give our systems private IP addresses inside of the environment. And only public IP addresses for things that need to be reachable. So we're minimizing our attack surface there. When we have an endpoint, we want to protect that endpoint too. So let's say we have a next generation firewall protecting our organization. And then we have a web server. First, we protect that web server from that next generation firewall. And then we might use a WAF too. So if we think about something like this, let's say here's dangerous internet. I'll call it dangerous internet, because this is a scary place. And let's say here is going to be your protected resources to a degree. Maybe behind the dangerous internet, we use a series of firewalls to protect us. So we've got some next generation firewalls. And maybe we even have some IDS, IPS systems over here, even though they're included in the next generation firewalls. Let's stick a content delivery network out here too while we're at it. Bear with me. Make this a little smaller so we can do it. So we've got a content delivery network because that can help us mitigate DDoS attacks and do all kinds of things for the reasons I showed you. Now, let's say this is our load balancer over here. We're going to want to do something to protect this load balancer to determine what traffic's even going to be allowed to actually reach our web servers that are going to be sitting behind the load balancers. So as you can see, these are all network security devices we're using. The CDN, typically speaking, has a good DDoS protection on it that won't send bad requests to your web servers. Your next generation firewalls, we can set it that it only allows TCP traffic port 443 if we want, or HTTPS, only going to this particular subnet or the particular address of this load balancer. And only web traffic's allowed to that load balancer. The IDS IPS system will be watching, and it can potentially stop and track, like reset a TCP connection if it has to. Then we protect the load balancer, and then we're protecting these web servers with endpoint protection, anti-malware. And we already talked about IAM and other things. So all this stuff is networking. And we're going to want to use as much of that network security as we can because it creates a lot of environments. Now, what we might do on the web servers of the load balancer is now we might put a web application firewall over here. So if we deal with the next generation firewall, for the most part, it protects our organizations from harm. And it protects most of the attacks we need to worry about. Now, a web application firewall, which often can be applied to the load balancers, the web servers, is more designed to protect just web applications. So it's going to be typically layer 7, and it's going to be really going to be great at web. So we might use 1 or 2 layers of next generation firewalls, and then we might put a web application firewall on our web servers, for example, and that's going to protect against web attacks like cross-site scripting attacks or cross-site forgery or SQL injections, and hopefully the applications are designed to protect that as well. Now we've got the concept of VPC firewall rules that are just going to allow traffic in and out of your virtual machine. So firewall rule, and that's going to feel a lot like an AWS security group to you if you're familiar with AWS. So let's talk about private access, for example. So if we're using private Google access, we don't need external IP addresses for anything that's actually inside of our environment. So we can use that. So if we think about that, on load balancers, for example, we're going to place our virtual machines behind the load balancers. Just like I showed you, we're not going to expose the virtual machines to the world. So even that, we can put some security on the load balancer, typically speaking, and further protect our environments. And we talked about VPC service controls to determine what's allowed in and out of your environment. So that will protect against data exfiltration or taking data. So while we're here, let's talk about identity-aware proxy. So we can implement an identity-aware proxy that can control user access to applications, and therefore eliminating the need for the VPN and provide some form of context-aware security for better experience. From a networking perspective, we're going to monitor the network logs and make sure that all of our logs are going to be monitored by the security teams to detect any malicious activity. And hopefully these logs are going to a security event monitoring system, a SIEM system, to try to look at those. We're going to want to do some form of resilience testing on these systems. We're going to want to try to introduce faults, shut down things, and make sure the system still stays secure. And we want to map out and document any kind of network access pattern. So we need to know what the network flows are supposed to be. So that way we can create the right architectures, not ad hoc think about each thing. Now let's talk a little bit about application security. Now remember, it is a shared security model. You're responsible for your stuff, and the cloud provider is responsible for their stuff. So one thing to think about at the application layer is we want to use IAM. So we want to follow IAM best practices, things like principle of least privilege, to secure access to our systems. We want to ensure that only authorized people can access the systems, and best practices include things like not using passwords, that kind of thing. Now we want to encrypt any traffic that's in flight whenever possible. So we want to avoid unencrypted things. So if we've got to manage something, the engineers have to manage something, we want them to use SSH, for example, to reach something, not clear text traffic. But why not use TLS security on any time your data is moving? So we want to encrypt our traffic anytime it's moving. And if we use certificates and certificate authorities, it's going to make it a lot easier for endpoint verification and setting up encryption using public key cryptography. So from a network perspective, we want to make sure that the traffic only flows on the network in the way we want it to. So that's why our network architects are going to help do this traffic engineering, if you will. Now, from an application perspective, we always have to harden our configuration resources, disable unnecessary service, minimize things that are exposed to configuration, anything we can do to reduce the attack surface. We typically want some good centralized logging with monitoring with all of our resources so we can catch events and correlate them in real time. And we should have a good image repository. So we should take images that we know that have been hardened down and locked down that are approved by our organization and put them in a repository so everyone can use the same hardened image or trusted image that we've determined we're going to use as a company. So, they would tell you best practices, leverage managed services whenever possible as part of your exam. I'm going to tell you as an architect, do what's in the best interest of your client after evaluating all trade-offs and the client's business needs. So use like an OS login to link SSH access to Google identities, and that'll make it easier to monitor and govern who has privileged access to virtual machines. We may want to enable automated upgrades and patch managements when possible to keep systems secure and up to date. But we may also be in an environment that you need to test the patches before they deploy them for security. So all these things we need to think about the implications on the business. One thing that will help us is to use templates for infrastructure management. Programmatically manage these things. Use infrastructure as code. Template the perfect configuration and use that way to deploy it. And that way we don't have all the human intervention of 100 people doing it their own way. Anytime you can deal with APIs, you want to manage them and manage them well. Using something like Apogee or Cloud Endpoints to kind of protect access to your applications. There's all things that go into data security, and you need to critically protect your data. Secure your data, classify your data, encrypt your data, create the right policies of who can access the data and under what circumstances. Because data exposure gets expensive. It's estimated between $150 and $250 per person's records that are lost. So imagine having 100 million people's records lost at $150 to $250 each time. Gets pretty expensive. So we have to think about that. So we want to use default encryption at minimum, which is AES 256. If we need full control over encryption keys or we need higher encryption, we can use so. But external key management options we have for critical environments. Otherwise, we can use the Cloud Key Management Service and the Cloud HSM. For things like organizational management, we can use the Cloud Key Management Systems or Cloud HSM to securely manage and protect key encrypting keys. We would like to use client-side encryption whenever possible. So what does that mean? If you need extra layer of protection to be on server side, encrypt it on the client before you even send it to the server. Follow IAM best practices whenever. And when you send data from point A to point B, send it securely. Encrypt the data. Make sure the data hasn't changed with your hashing. And make sure that it's stored in an appropriate environment where it's still secure. Now, when it comes to data security, we're going to want to classify the data. Sensitive, non-sensitive, top secret, protected, I don't know, but every organization is going to need to come up with a data classification environment and a model to make sure that various types of data are protected as they need it. We typically want to use some form of a data loss prevention tool. Google has their own cloud data loss prevention tool. They can discover, classify, and protect sensitive data, either when we ingest it or when it's at rest. And of course, DLP systems, some of them out there, the commercial ones can actually do egress monitoring. So they can monitor on the way to the internet if sensitive data is leaving your system, and it'll block it if that's the case. So we want to use some form of tokenization or obfuscation or some form of data minimization information, especially personally identifiable information. We really want to tokenize that, replace it with something that's not sensitive, for example, to reduce the exposure of sensitive data. Now, when we have databases, we want to use good security on our databases, good schema design to make sure our tables are properly designed and secure, and also chain views to make sure that not everybody can access all data. Now, we want to integrate security into DevOps pipeline with things like DevSecOps. So that way the application security is in mind. It's tested for security vulnerabilities as it's being built, what have you. So we want to really integrate that security across the entire life cycle, from the time it started to the time it's going to be decommissioned. We also want to do threat modeling, and again, much more on the CCSP program about threat modeling, but it's designed to figure out what kind of threats and what kind of risk we face and what are the threat vectors or means of attacks that someone can attack us with, so then we know how to protect our systems and create the right architecture to protect us. From a code review perspective and peer reviews of the code, we definitely want that. So let's think about some best practices for securing DevOps pipelines. We want to do some vulnerability tracking and remediation tracking every time we create code. So we want to continually track and remediate vulnerabilities. We want to do static code analysis, dynamic code analysis, penetration testing, ethical hacking on our systems when they're there. We want to deploy our systems, like I said, with infrastructure as code to make sure there's no configuration variation or configuration creep, if you will, from human error. Now, we want to make sure in our DevOps principles, we're very good with key management. We make sure we eliminate any kind of embedded credentials in the code. We definitely don't want that, especially when people put it in a public code repository and they leave their credentials there. That's a real nightmare. We want to manage privileged accounts so we can control who can do administrative things on our system and reduce that to as little people as possible. And we want to protect our service accounts, especially those that need very high privilege to go from one system and connect and talk to another one. So there's a lot that's going to go into security. There's really going to be two focus areas, either security of the infrastructure. Now, that could be the network design, the secrets management, the data pipeline. But we also have to focus on the operations, the people that are running and managing the system. So that could be a SOC team, for example, security operations team. Which also means we need a good security operations center and some good detection and response teams, either or. So the whole point of having these security operations centers is to detect bad activity, respond to incidents, and provide feedback to mitigate and prevent future incidents. So in a small organization, this might be tough to have dedicated people that sit around and wait for stuff to go wrong and then fix things. But in a big organization, you may need this. Now, most enterprise organizations will have a dedicated team, and even medium-sized organizations, larger organizations probably still will. It's only in the small organizations that may be challenged. So if this is the case, maybe an organization might need to outsource to a managed service provider or a managed security service provider. Now, security people are going to need good, strong security skills, and that may be different technical skills than they would get from software engineering. I guarantee you they are. So when it comes to securing, there should be a good logging architecture where we take all these logs and we secure them into a place that makes sense, like a SIEM system. We determine how we're going to ingest the logs, and the security engineers will be working on that. They'll work with the cloud architecture team to help identify relevant logs and then build pipelines to get the logs. We want to be able to correlate the logs on alerts. So we get an alert and see all kinds of log changes. We want to correlate that and see what happens. So your times obviously have to be synchronized when you're collecting logs, but that's why these SIEM systems exist. We want to have some good alert analysis and hands-off. So alerts, when they're analyzed, of an indicator of compromise, if you confirm an incident, it needs to trigger a formal incident response workflow that's been designed ahead of time. So if this happened, these are the steps to do it. And you want this pre-planned ahead of time so you can do it calmly. And of course, incident response. If the incident response team is activated, they're going to need to contain the incident, eradicate it, and then recover from the incident. And there's going to be a lot of roles here, like incident manager, communications leads, subject matter experts, attorneys that speak to regulators, who speaks to the press. And of course, after any of these things, you want to get some feedback. Okay, we're back. We've got one more security video and then a little bit of billing and support to finish up this Google Professional Cloud Architect Bootcamp. Wanted to check in and see if anybody had any questions. Make sure that if you just found us out of nowhere because you were searching something and YouTube sent you here, or Google search sent you here, to let you know that There is a playlist available to watch the previous 8 days of this completely free Google Professional Cloud Architect Boot Camp. My team will drop the link to that in the chat box. Please enjoy it. Go back and watch it again prior to preparing for your exam as necessary, and the such. So, kind of keep that in the back of your mind that we've got a completely free boot camp that you can do, and we've got a completely free study guide. My team will drop a link to that study guide to get you here. It is clear we are in the midst of some fairly significant outages that are going out there. There's some outages at multiple cloud providers going on right now that they're reporting it. There's some outages at various internet service providers. Here's what you can know about a good architecture. It works. If you notice, YouTube is still up in the middle of multiple internet service providers and cloud providers outages, and that's because they host multiple data centers. Some of YouTube services you can look on Google and you'll see are hosted on the Google Cloud, and a lot of it is hosted in private data centers. So that's exactly like the hybrid multi-cloud architectures that 98% of enterprises have. And here's the reason why. Well, some companies that are using a single cloud or a single provider are down. Other companies are up. Or some companies are on a single internet service provider, a single content delivery network provider, a single cloud could be down, and other well-architected companies. And look how good and solid YouTube is. It's up and it's running. So we don't exactly have any idea what's going on yet, but look, they're still running. And that's generally the hallmark of a quality architecture, to make sure that it can withstand all kinds of failures and things going on, whether they be hacking events, whether they be DDoS issues, whether they be core internet routing issues, cable cuts, cloud provider outages, just any of the normal things that happen. Because no matter how good you are, and believe me, they're among the best of the best, stuff happens. So I guess it looked like a lot of people wanted us to talk about multi-cloud architecture. So I'll do a one day next week. Chris will pop a link up to sign up. We'll do a 2-hour webinar. We'll talk about why people go high availability. What is high availability? What is not high availability? And all the little gotchas on the high availability way that'll get you. Even if you did everything right, you'll still go down because of all those lessons learned. Now, this is going to be the kind of insight you would get of 10 or 15 years of learning or making mistakes, or listening to someone from me or David Lethwick, who was designing these things for decades. So we'll have a free one. We'll run it either on Zoom or YouTube. Not sure yet, but we'll make it available so people can see it after the fact. So yeah, we'll make sure we do one. We'll make sure you guys sign up for one, and we'll do anything we can to help you. And we'll do it next week. Jacques said, have I worked in my career for companies that required security clearance? So, Jacques, I'll tell you why I didn't need security clearance. I've trained people that needed security clearance, but I'll tell you why I didn't. Now, I've been background checked, I've been fingerprinted, I've been drug tested by every company. But to me, if you look at the opportunity that's out there, the opportunity to global bank, an opportunity at a global enterprise will pay often 2 to 3 times more than the government jobs for which you need security clearance. So for me, I really wanted to work with the world's largest banks, the world's largest internet service providers, design parts of the internet and make it work. That was me. Now, if I wanted to work on a military base, and I have lots of friends that are in the military and I completely appreciate what they do, I actually tried to enlist in the Marine Corps at 18 years old. It didn't go my way, but so be it. But so it's not that. It's just that I like to work in the private sector. I like to be able to change the key processes to make a difference, and I like to be able to see the results of what I do. And a big organization, when you look at the enterprise architecture of a giant company or a government, in order to make that work, you need a whole lot of structure, a whole lot of rules, and very tightly coupled business processes and applications, because that's the only way we can manage something that's big. Now, me personally, I'd rather somebody say, Mike, this company's got this problem, this problem, this problem, this problem, and this problem. Go figure out how to do it and go be yourself. And my process might be go to the beach and practice yoga. And then in the middle of a savasana, I've got an idea that I want to go talk to people about. And that's the way that I've ran my career. So kind of hope that helps. But there's lots of great jobs for people that want to work. And I've gotten people in military places where they need security clearance. But for the private enterprise, you typically don't need it. And you generally don't need security clearance to work in security architecture. That's more of a government thing. Great question there. So seems like we've got about a 19-minute. Like I said, I pre-recorded this because I had some medical procedures done, and I wanted to make sure we could deliver it with excellence, whether I was able to do it or not. And then a little video about support, which is probably about 15 to 20 minutes. And then we are finished, and we got through a little early, and you guys will be prepared for the Google Professional Cloud Architect exam, and look forward to hearing more. If you let me know you're awake and alert and oriented, give me a hashtag Google Professional Cloud Architect or something to that effect, or tell me security's fun and you like cybersecurity because I love security, or just let me know that you are there. Adrian's good to see you. Jacques, good to see you. I see some names of people that are there. So let us know that you're there. Give me a hashtag Google Professional Cloud Architect. And Chris, let's move on with the content. We're going to continue our discussion in security, specifically about security operations. So we want to use automation here when we have possible. More and more AI and machine learning services are coming out, and we want to use as many as we can. We have AI in our firewalls that can recognize attacks and stop attacks. We have AI in our SIEM systems, for example. They can look at logs, recognize attacks, and potentially stop attacks. We can have context-aware IAM that looks at a whole bunch of things and makes sensitivity and risk decisions to determine to allow or not allow, or to allow with an MFA challenge. So we've got a lot of AI that we're using to protect ourselves, and it's getting bigger and bigger each day. So we always want to think about how do we automate, because the reality is, in most cases, we've got understaffed, overstressed teams. Because, organizations don't have anywhere near the money for security that they typically have for other things. Security is typically an expense, whereas like a salesperson is typically someone that brings money in, but we need the security people, and they're critical. So what we need to do is have the right people with the right set of skills and keep them able to do their job by not focusing on menial tasks. So that's why we're going to try and automate as much as we can. Now, for any of this stuff to work, we need a lot of collaboration between organizations. So we have to think about what needs to go on. Now, we have to basically come up with some form of an incident response process. And typically what happens is we prepare for the incident. So we plan, we test, we make sure that our architecture is good. And then what happens, we continually start detecting and analyzing what's going on. Is there anything going on? Is there something going on? And if we find an incident, then we need to contain that incident and keeping it as minimal as possible, eradicate it, get rid of it. And ultimately, we have to get our systems back to where they used to be. And then, of course, we go to a postmortem phase. So maybe I'll draw that out. Now, there are lots and lots of incident response plans and procedures. But if we think about the first phase being preparing, so what are we really talking about? We're making sure that we prepare. So we create an incident response procedure. Who does what teaches what. We then test the process. We then train people on the process. We put all our architectures in. We prepared for an attack, right? But no matter what we talk about, things will happen. So that's why we're doing all these things. We're now detecting. So we may have these logs. We're detecting with logs. Our SIEM systems are doing some detection. Our firewalls are doing detection. Our IDS, IPS systems are doing detection. So we've got all these kind of things that are going here. And then as soon as we get it in something, we want to contain the incident. So the first thing we want to do is contain what's going on. Because let's say they're in our systems. We want to keep them to maybe one VLAN or one server and not let them there. So the first thing we do is contain the incident until we know what to do. Then after that, we have to fix it, and it's considered eradication. We have to fix the incident. And then after that, we have to recover from the incident, which is bringing the systems back, re-imaging the systems, for example. Or build a new server, create a new security protection mechanism for this. We have to get back to what the system should be. And then after every event, we probably need some form of an after actions report, post-mortem or whatever you want to call it. So I'll call it after actions report. But here's where you assess what went well through any of these steps, what didn't go well that we need to do better in the future. And that's typically what we're talking about here. And all these things should go back into the better pro. So we have to inventory our assets, and that's going to bring us to a cloud asset inventory. If we don't know what we have, how can we secure it? And I'm going to tell you, in my youth, I used to go search around with a protocol analyzer, and I'd find systems on the network that nobody even knew we had. Now, the better we know what our systems are, obviously, the better we can protect them. So the cloud access inventory is going to give us metadata. Remember, we have metadata or information about our things that'll help us track and manage our resources and assets in Google Cloud. So it will give us some good visibility into the entire infrastructure, which is going to be absolutely critical for strong governance and management. So let's talk about it from an asset management perspective. Knowing what our assets are is going to be obviously important. If we don't have this visibility, how do we manage or even secure things if we don't know what we have? So asset management is going to be critical. We're going to have our assets. We need to tag them. We need to organize them. And that way it becomes easy to deploy changes or manage things when we need to. Now, we need to be able to detect changes. So cloud asset inventories can be used to scan the infrastructure for changes and detect unauthorized or unexpected modifications. So from a policy perspective, we need to think about how do we push policies across the infrastructure? How do we enforce our security controls? How do we enforce our organizational policies? So we might want to think about compliance auditing, and none of this is going to work if we don't know the assets we even have. Now let's think about an incident investigation. If a security incident is going to occur because a firewall rule was left open or something was left open or unpatched or what have you, at least the cloud asset inventory will give you an analysis of what's going on, who made changes, when the changes were made, and we can trace it back. So we need to be able to know what happened, know when things break, and know how we can fix them. So by building us a good asset inventory ahead of time, we can make sure all the teams are talking before we have a problem. We'll be able to think about how to secure everything before we have a problem. And typically organizations are supposed to have very good architecture repositories with diagrams and documents explaining things, explaining how these things. So hopefully you've got a good architecture repository. But I've got to tell you, unless an organization has a very good architecture practice, and typically a lot of cloud architects and enterprise architects, they're not going to have very good documentation. And then we may need to use this cloud asset inventory as a means to start being able to document things. Now, we typically need what's called the Security Command Center. And that is going to be something that's going to help us figure out the security management, what we have. Now, Google has theirs. And it's going to be a security and risk management platform that's going to, in Google Cloud, that's going to provide visibility into various security elements. So Google Cloud will be called the Security Command Center. And that's going to integrate well with the Cloud Asset Inventory, allowing it to sort of monitor and analyze your infrastructure, constantly going for security risks. Now, don't believe this is going to give you all your information. It, again, is an automated tool which gives you information, but keep looking. So we've got some core tools with the Security Command Center. You've got some good threat detection, which typically identifies potential threats in real time. We've got some security health analytics data where it's constantly analyzing the health of our security configurations, and it will flag any potential vulnerabilities that it sees. We may have a web security scanner that's going to be scanning, say, web servers for vulnerabilities like cross-site scripting attacks or maybe some outdated libraries. We'll have access to additional tools that can really enhance our security visibility across the Google Cloud. So it'll give us some security findings, which will help us analyze things. So when a flaw or issue is going to be identified, the Security Command Center will generate a finding report. It's going to give you insight into who, what, where a change was triggered. And these types of helping you figure out these things enable security professionals to trace incidents back and identify the root cause. You want to know why you were hacked. If you don't know why you were hacked, how are you going to go fix it? So from a workflow integration perspective, the Security Command Center You could work with it directly, or you could export this information to a SIEM system like Splunk, which you probably want to do. And that's going to give you much further analysis using the organization's native security tools. And we start thinking AI in these tools. So you definitely want to use some good form of a SIEM system. Now let's talk about detecting threats. So you typically want to have some type of environment to figure out what the risks of your environment are. And Google has cloud threat detection, and that's going to be one of the logic engines inside of the Security Command Center that'll give you automated threat detection. So there's some tools involved in the cloud threat detection package, and that includes event threat detection. And what that will do, it will focus on log-based threats, and it'll identify logs that look for compromises in the organization. It may be, it may not be, but it'll alert you. We have container threat detection, which will focus on container runtime threats, detecting threats inside of your containerized environment. We have threat detection and automation, so we have what's called threat signatures. Now, traditionally, security teams can build what's called a custom threat signature to identify potential compromises. So let's talk about what a signature is and why it's kind of outdated in today's world. So here's what a signature is. So let's say I have a known attack A. In a signature-based model, what I can say, I can say, we know what known attack A looks like. It's got a particular signature. So anytime we see known attack A, signature detection says block from whatever happening, and then we're protected. So that's signature detection. Here's the problem with signature detection. It's already a known attack, but what if we don't know about the attack? Well, if we don't know about the attack using signature basis, it's called an unknown attack. And because it's an unknown attack, signature protection doesn't know how to fix it because it's never seen it before. Now, we have other more modern platforms that are using more AI, and what they're doing is behavioral threats. And any kind of a system we want to use, we want to use behavioral. So now an unknown threat comes in, and the behavioral application says, this doesn't look right. This looks like an attack. I'm going to block it anyway because it feels like an attack, even if I've never seen it. So signature-based is very outdated. In today's world, we're using too much more. Google will help automate threat detections by leveraging many tools that it actually has, which reduces the complexity on the security teams, enable them to focus on other tasks. If you need more, please consider using industrial third-party tools. And most enterprises need more. But if we think about workflow and integration with cloud threat detection, the results of threat detection findings can be exported to your SIEM systems. Great, you want to do this. And that can enable your security operations centers and other teams to basically have good information in close to real time to do something about it. So for smaller organizations don't really have a budget for a security event monitoring system, they can use the Security Command Center to get good enough information if they are not high risk. Realize enterprises will probably need more. They will probably need a real SIEM system here, or a heavy-duty industrial SIEM system. But cloud threat detection does give you a lot of efficiency because it has some pre-built detection type controls that can look and protect you from an environment. It has some things that are automated, and it will help an organization improve its security posture. So let's talk about security health analytics, and that is also part of what we're looking for from the Security Command Center. And security health analytics is going to be another tool. Now, it's going to be focused on Google-specific vulnerabilities, such as an open firewall rule that you left, or an open Google Cloud Storage bucket that could be accessed from the internet, for example. It's going to look for host-based vulnerabilities like those that are covered in virtual machines, which are not going to be covered by secure health analytics and would typically be handled by other tools. So We have to think about what it's covering and what it's not covering. It's going to be Google specific things. So those kind of host-based things you're not going to get. So you might need another tool for that. Now, when it comes to security health analytics, it's going to be constantly scanning, or at least periodically. So it will scan your inventory, the cloud asset inventory, about every 12 hours to detect vulnerabilities in your environment. And it's going to have pre-built scanners that are going to just scan your environment and detect vulnerabilities in Google. If we think about where this is going to happen, because we've got the ability to export them, we can deal with two separate teams. We've got the vulnerability management teams that are typically going to be responsible for remediating vulnerabilities, not the SOC team, the security operations team. And then we've got the security operations team that's more focused on threat detection and incident response. So, and while the vulnerability management teams are going to patch systems, so we're going to need a lot of people working together. Now, let's talk about the organizational structure. In some organizations, vulnerability management is conducted in the operations teams, but their job functions are distinct. So whatever we're dealing with, security health analytics team supports vulnerability management by automating the discovery of Google vulnerabilities, enabling faster remediation of Google Cloud things. Now, we also have something called a web security scanner. Now, that is a tool inside of the Google Cloud platform that's going to scan public endpoints for web-based vulnerabilities. So anytime a web vulnerability, it's a web vulnerability scanner. So it could be an internal web-based application or an external web-based application, anything you're using like HTTPS, for example, or HTTP. So it can work with a lot of resources such as Google Compute Engine, think virtual machine, Google Kubernetes, think Google managed Kubernetes, Google App Engine instances, those types of things. And the website scanner is going to scan for common web vulnerabilities that you might see, like a cross-site scripting, the ability to do a cross-site scripting attack or clear password fields or anything like that. And vulnerabilities that are going to be detected are going to be based on the OWASP top 10 web application security lists. So if we think about the web security scanner, we're going to focus on applications. It's going to be there protecting of web servers. It's designed to identify security issues on web servers hosted in the Google Cloud, which gives us the ability to be proactive and protect our applications for things and make sure we detected things, for example, insecure password fields or cross-site scripting, anything we can do to strengthen the security posture. Okay, well, we are back, and that is the last of the security section as it pertains to the Google Professional Cloud Architect Bootcamp. We still have more content today. Now, I do want to say there is only a very small amount of security that's actually in the Google Professional Cloud Architect certification. And, if I was going to train a security architect, and I have security architect training programs, we give them everything that it takes to be great at their career. But if security architecture is not where you're going and you're more into cloud architecture, I still recommend you learn more. And if you're in an engineering side, I still recommend you learn more. And at least something that'll give you a little more of what you need to know is the Cloud Certified Security Professional that we have, the CCSP program. That is going to give you some extra cloud knowledge. It'll help explain the idiosyncrasies and the challenges in cloud security that are different than traditional security. It is a highly regarded professional security certification. And my team and I put a lot of effort into creating a free CCSP bootcamp. And if you wanted even more basic, we've got a free CCSK bootcamp, which you could do and then do the CCSP bootcamp. Not that you would need to, but if you wanted to. But I want to make sure you know there's many more cybersecurity resources that are actually here to assist you. And if you want a full blown out security career, then join me on a webinar on how to become a cloud architect, and I'll cover the security architect role. Now, the next part is just going to be a little bit covering billing and support. It's a very small part of the exam, and that's why we've got a small component. We'll talk about it for about 30 minutes. And then after that, we've completed the 2-week Google Professional Cloud Architect Certification Bootcamp. And of course, you've got that free e-guide. Please go get it. For the Google Professional Cloud Architect, sign up. My team you'll sign up. My team will drop the link. It'll be emailed to you. So hopefully you're having a good time. Maybe you can give the video a like. Maybe you can share this share these videos with others that you know, because it takes a lot to put these together. Maybe you want to join our channel, hit the bell to be notified of other stuff in your career. So do that. Give me a hashtag CCSP so I know you're awake, alert, and oriented, because we really want to try and give you as much as we can. We'll go through this next 30 minutes, and then congratulations, you finished it. You'll be all prepared for that Google Professional Cloud Architect exam. Maybe you go through it a couple of times first, but you'll be prepared. Chris, let's roll with the content. In this section, we're going to discuss billing, migration, and support. And of course, this is to prepare you for the Google Cloud Certified Professional Cloud Architect exam. So we'll begin with billing, migration, and support. Now, we have to think about billing. Now, in order to optimize your cost, at some point you need to know what your bills actually are and then figure out what's working, what's not working. Now, the key to minimizing bills is the proper architecture in the first place, moving the things to the cloud that make sense to move to the cloud and not migrating things to the cloud that don't. For example, high-use virtual machines that are high throughput, using high use all the time, may be substantially cheaper in the data center, while as sporadic information, for example, sporadic use might be much cheaper in the cloud. So we need to know what we're moving and why we're moving it. And there's going to be lots of different billing environments we could deal with. We might have a startup who basically puts their cloud expenses directly on the CEO's credit card. Now, if we're dealing with a large organization, they may funnel expenses through a single division, or they may require each business unit to manage its own cloud costs. So when organizations get big, there's lots of ways they're going to be managing these costs, especially when you start thinking of a multinational corporation with multiple various discrete business units. So what we can do is we can do organizational labeling of the Google Cloud, the account. And that way we can ensure that the proper cost management is there for each division. We're tracking cloud expenses, what have you. So when we think about going from the data center, we know what our expenses are going to be. They're basically going to be the same power, the same employees that we've always had, but the type of technology, we can control it. We bought it, and unless we buy new, we're not paying extra. We're just paying either nothing because the gear's paid off, we paid for it in cash, or we're paying the financing charges on the gear that's there. One of the two. Now, that's a capital expense for the most part, buying the gear, whether it's financed or not. Now, when we go to the cloud, that becomes an operational expense, and instead of paying for things, we pay a lot more for each thing that we typically use. And now that becomes an operational expense, which could be good, could be bad. It all depends on the organization's capital structure and other factors. So keep that in the back of your mind. But imagine getting one giant bill for an entire organization with 10 divisions and not knowing where it's come from. So that can be overwhelming, and it would require careful accounting. So we can think about how we do the billing and how we separate it out. So think about that. Now, when we go to the cloud, it's going to cost a lot of money to do it. We have to think about all the planning, all the steps that need to occur. For example, all the people that'll be there, the architecture, creation of the architecture, the training of the users. So there's a lot that's going to be there, and we've got lots of options. Do we just pick it up as it is? Do we tinker with it a little bit? Do we completely re-architect it? So there's going to be a lot of options what we can do, but proper planning is going to be the right one. Now, we have to make sure that we have the people that can even use the systems on the cloud. So we have to think about that. Do we have the people that know the cloud? Can they use it? And then we need to think about support in the cloud. So we don't just have our own stuff that we need to worry about in the data center, which is what we do. Now we need to worry about the cloud provider stuff going down. So what happens when they're doing upgrades or maintenance, or the developers are making a mistake? And believe me, mistakes happen. One of the clouds went down for a day, practically a day, because someone made a BGP error. Other clouds get hacked or are down. So there's lots of things that are going to go on from an operations perspective, and issues will arise from your cloud providers. So you want to make sure that you've got strong support, and that you're dealing with an organization you trust, and that you're following best practices, and you're doing everything you can to enhance the overall reliability of your architecture. Now, costs are going to be determined by how much you actually use. So the cloud's very cheap when you don't use it, but when you use it a lot, it can get very expensive. Your virtual machines, the storage, your databases, all this stuff can get pretty expensive. So what we want to do is think about how we create these organizations and how we label them from scratch. And this way we can get granular on cost tracking. We know this cost is coming from this business division, for example. And by doing so, then we can create a better budget and we can create a better forecast. We know what our costs are going to be. So we have to create the right budget and create a forecast. In general, when we create a budget, we should leave a little room for error for things that we don't plan on happening, but will happen or could happen. It's always a good thing to do. And if we're dealing with disorganization or billing and budgeting, imagine the labor cost of having an army of people mine through the data. Whereas if we set up the billing correctly and we organized it correctly, it's pretty simple and we don't need that staff. So kind of think about that and its impact. Now, we could do a single account billing. And in a single account, realistically speaking, we've got a single support contract. This is typically very easy to manage, just a single account. Now, if you create multiple billing accounts, which you can do, and in many cases is going to be necessary for a multinational company where different divisions might have different billing needs, and basically each billing account will operate in a single environment, single currency, and if multiple accounts are needed, they'll be obviously paying in different currencies because they're now in different countries, what have you. So single account, great and simple. Multiple accounts, great when you need to do multiple accounts. So we have to define what is a billing account. So a billing account defines who pays for the resources, including the Google Cloud, Google Map platforms, APIs, what have you. And that's going to be managed with Cloud IAM. And it's going to provide a single invoice per account. Now let's talk about project and billing account linkage. When it comes to project linkage, all projects should be linked to the billing account that's going to use as paid services. If you log it to a different account, well, obviously, you're not going to get any information there. So we should be linking all projects to the billing account that's using the services. Projects should not link to these, can only use free services. So we need to get this right. And any kind of online or offline billing, these kind of payments could be made through a credit card or a debit card or an ACH direct deposit. And an offline account, by comparison, a payment will be made via a check or a wire transfer after receiving an invoice. So let's talk about some key roles that we're going to create when it comes to billing. We have the billing account admin, and this is managed via Cloud IAM. And this person can typically enable billing export, view costs, set budgets and alerts, and link and unlink projects. Now, this is typically a role, the billing account admin, for somebody that's going to be on the organization's finance team. Now, we could also have a billing user, and this is also going to be managed via Cloud IAM. Now, here, this person can link projects to billing accounts, but they can't unlink them. They're usually assigned to a project creators to ensure project linking and billing. Now, we also have what's called a payment profile admin. And this is going to be managed outside of GCP in the Google Payment Center. And this is where we manage the payment methods for the account for, say, Google products and services. Now, strong naming conventions are going to help us a lot. If we know what our systems are and we know what we're paying for because we named them intelligently, we can figure out where our costs are. So we typically want to label things. We can integrate that into infrastructure as code templates when they're coming out. We want to know what our systems are. If we don't know something, how do we know where the money is going? We just don't. Now, if we think about infrastructure as code, we can label things, and as we're building them, it also reduces the likelihood of mislabels or rogue resources where someone turns it on, we don't know what it is, and then we're getting billed for it, and we can't figure out what it's associated with. We also want to track budgets in cloud billing, so we want the teams to consistently monitor their bill. And that way, if you see something that's going wacky or becoming expensive, you can create a new architecture to fix it. And we may want to export our bills to BigQuery. Again, that's a data warehouse, so once it's there, we'll be able to look and analyze what that data actually is. Now, when it comes to cost control, cost awareness is a shared responsibility. It is an enterprise-wide or company-wide responsibility, not just for the finance team, to be careful about what you use. Use things that make financial sense. Just like security, everybody needs to be involved here. And we have to be very careful of the risks of uncontrolled costs. So imagine we've got a large query, such as a petabyte-sized query in BigQuery. That's going to get expensive pretty quickly. So you've got an inexperienced data person, and they're trying to run a whole big multi-petabyte queries, and you get a pretty large bill, and they don't even know why. So we have to think about how we're using these things and be smart about it. Cost alerts and budget control. You can set up an alert like a budget, and that'll alert you before you reached a certain percentage of it or yield a certain percentage of it. This, all the cloud providers have this. So when it comes to cost control, we want to view, we want to analyze our costs, we want to create console reports, invoices, BigQuery exports. We want to understand where our costs are coming. If we made something a function as a service, and that function is running all the time, and it's much more expensive than a virtual machine would be, take that thing and turn it back into a virtual machine and run the virtual machine, just like AWS did. For example, they found that Amazon Prime, which was using serverless, was costing them 19% more in that serverless kind of environment. And when they switched it back to a monolith, they saved money. And I'm not saying pick any architecture ahead of time, figure out what's right for your clients. But as you monitor systems, you'll know what makes sense and what doesn't make sense. So we also have the Google Data Studio, and that can be connected to BigQuery data sets. So we can create a dashboard and get powerful visualization and see what's going on billing-wise. So let's talk about the types of discounts we can actually get with the Google Cloud. Now, with all providers, if you agree to spend a lot of money or a certain amount of money over a period of time, they're going to give you a committed use discount. So these can be some fairly good, strong, significant discounts. If you specify, I'm going to use these 1,000 virtual machines for the next 3 years straight, for example. And by doing so, the Google has predictable revenue, and that's worth a lot to them. They can give you a discount. It helps them determine what capacity they need or not need so they don't have to overbuy. So if you forecast your demand and you understand what you're doing and you understand the use of your traffic, this could be great. If you don't understand the use of your traffic and you overcommit by 10 times because you don't understand your traffic, well, then that's going to get very expensive. So you really need to plan everything before you make a migration. And we also want to think about sustained use discounts, and these are going to be automatically applied based upon how long a resource has been running inside of a month. So if we have virtual machines on Google Compute Engine for 90% of the month, that could lead to a discount of upwards of, say, 30%, depending upon the type of virtual machine. So they're giving you a discount for using it for a period of time as opposed to just for a few minutes. Now, you can use preemptible virtual machines. Those are those instances that you bid on, and it's unused capacity. If somebody bids on more, they shut you down. So these can be some very good discounts if your workflows allow start or stop and they're not critical. And of course, if you're a large customer and you have your own dedicated account team, you will get very good contractual discounts, which you will negotiate with the Google Cloud sales team based upon the committed deal, the size of the deal, and we can be talking some substantial discounts here. And this is going to be common practice to give some discounts for people that are big businesses that are going to be there, especially if the big businesses, I'll issue a press release that we're moving to Google, and any provider does that. So when it comes to anything, we need to forecast what our expenses will be. So we can figure out if we forecast better, then we can get any kind of discount we can plan for. Virtual CPUs, memory, GPUs, SSDs inside of a region. And we want to forecast and plan our usage. We've got to be good at it. So we want to take advantage of a committed use discount when we had, because anytime we use these systems that are just on demand or whatever you want to call them, they're usually going to be more expensive. But if we don't know what a demand is, we've got to use just whatever we turn up, use it, and then shut it down when we're done until we figure it out. So figure it out ideally before you go to the cloud. Now, migration planning is not a simple thing. It can take dozens of people. So a lot of times when I would plan a migration or others that I would plan, it could take 15 to 50 people 6 months or more. to really figure out how to plan the migration, who's going to do what, when it's going to be due. Do we have the skill sets, the statement of work, all of it? It's going to take 6-12 months. I mean, it's not a simple thing. And, you know, we architects are going to work across our board of directors, the C-suite, other executive sponsors, senior leaders, architects, engineers, project managers, vendors. I mean, we're going to be working across all these things. And typically during migration, we typically have to hire additional people to help us migrate unless we have the staff. Now, there are Google teams that will help you with migration. There'll be obviously the cloud sales team, which will give you a solutions architect that'll help plan it, but they're designing, presenting, selling Google stuff. I guess they work for Google. Keep that in the back of your mind. Google also has a very good professional service organization, like all these tech companies, that if you want can help either do the install, plan it, coordinate it, execute it, or other type, and even manage it for you. There's lots of environments out there. So the Google Cloud migration methodology is like anybody else's. Assess the information first. Then do your planning of what needs to go and what should be moved. Define the order of your plan. Then determine whatever your migration path would be and then migrate it that way. And then as soon as you migrate it, figure out how to optimize it and fix things. Same as anything else. Now, before you use the cloud, you really need a good forecast. So that might be services that are going to be used, the applications you choose to migrate. What are the usage patterns going to be, which will give you spending projections? What kind of resource needs are there, availability needs? Now, we can do something called quotas versus capacity, and I want to talk about what they are. So we can come up with what's called a resource quota. And that's going to be usage-based restrictions that are going to prevent abuse or accidental overuse of resources. And every account will receive default resource quotas. Quotas act as a safeguard to protect you from exceeding your preset limits. For example, maybe you limit your development team to 2 petabytes of SSD storage in a specific region so they don't go to 100 petabytes with an application by mistake and cost a fortune. Now, capacity is a little different. Capacity refers to the actual amount of resources that's available to be provisioned in a region. You might have a region that doesn't have the capacity you need. I might need to use a different region. Or you're, in this case, telling it how much you're allowed to use in a certain environment, more realistically. You at the policy level. So this is a little different because now capacity is going to be developed on physical infrastructure limits as opposed to just what you set. You may have a zone that just doesn't have any more compute capacity, and there may not be any more in that region until it gets upgraded, for example. For example, you may request a quota increase for 2 petabytes of SSD storage in one of the regions, and the quota will limit what you can do. But if you need more, maybe in the region they don't have the capacity to get you past that because the infrastructure is already maxed. So let's talk about capacity reservation. So you can actually reserve capacity, things like memory, disk, and CPU for your organization by ensuring they're available when needed. Now, you may pay for reserve capacity regardless of whether you use it immediately, but it means that you don't have any resource constraints. So you might be in an area where there's limited extra capacity, and you want to pay extra to guarantee that it's there. Reminds me of the early days in cloud computing where you commit to a certain amount of guaranteed traffic going through your systems. Now, we also have these cloud scalability considerations. We talk about the cloud being infinitely scalable, but that's not true. The cloud resources, servers, memory, disk, GPU, they run out too. So we have to make sure we don't exceed the cloud provider's capacity, and we have to plan around it. So let's think about large, giant deployments, the kind of things that I've done for the last 25 years in all kinds of various architecture positions. When we're dealing with something massive, we first have to understand, does the capacity even exist? Do the resources we need even exist? Will the cloud be able to expand as we need when we need it? And then we want to come up with resource quotas that are going to be based upon what we need. Now, how do we get our data? Well, there's lots of ways we could do it. If we've got a wire or any kind of a private line to Google Cloud, we could use it. We have a VPN, we could use it too. But what happens if we've got a huge environment with regards to like maybe 25 petabytes of data and 200 applications and 10,000 virtual machines? Well, if we have enough time and a big enough network connection, we can do that. But if we don't, we may have to do other things to influence how we get our data there faster. And if we don't have time, we might use different types of appliances that we can put it there, which are basically a little computer ruggedized, filled with hard drives. We can copy our data to that and then ship that to the Google Cloud, and then they can put it on the cloud for us. Now, when we migrate, there's a whole bunch of options that you typically talk about. They often talk about the 7 R's. I'm going to talk about the main ones. Realistically speaking, rehosting. So you take a virtual machine or a container from your data center and you move it to the cloud. Rehosting, they call it lift and shift. Don't expect to get any digital transformation out of taking the things exactly the way they are and moving them exactly, because you're just taking the things different. So it's like taking something from one closet in your house, putting it into another closet, off of your data center public cloud provider. Now, replatforming is going to be a little bit different. That's like lifting and moving and optimizing along the way. So again, if we optimize the application for the business needs, it's going to help us. If we just optimize the application, it's not really going to transform anything in the business. It's just going to be a new version of it hosted a different way. But we may need to do that to get to some other future business things that we need to do. So we might want to take the application and migrate it to the cloud and optimize something. So change the application the way that it was actually running a little bit. Now, we may want to refactor it where we really move in and improve it. And with refactoring, we actually do a lot more changes to the applications as we move them. And we try to make them more designed to run on the cloud, more containerized, more serverless, if you will. So they're your basic options. And then obviously you can re-architect the entire thing. And in a perfect time re-architecture, you're actually dealing with the stakeholders, mapping out the business processes, mapping out the business value streams, and creating a solution to optimize business performance. And then the applications are going to be rewritten, re-architected, and placed in the cloud in the most efficient manner possible. So we have to understand that there's different cloud environments in different places, and they tend to work better. So there are basic options. Now, like I mentioned, we can send our data to the Google Cloud various ways. We can just push it directly over our private line. We could potentially do a online transfer, and there's lots of tools that we could use to do that. We can use what's called the storage transfer service, and realistically speaking, this is a way to transfer a tremendous amount of information. And we could also use what's called the transfer appliance. So in this particular case, a hardened computer is shipped to you. The computer is full of high-capacity hard drives. You copy your data onto this ruggedized computer. It gets shipped back to Google, and the staff puts it on the Google Cloud for you. Now, if you have a dedicated private line to the cloud provider, that could give you a lot of speed to get your data to the cloud. Like if you had two 40-gig link aggregation groups and you were load sharing because you had a good BGP policy, you can get a lot of data really fast. Not that most organizations have that. Now, anytime we're dealing with billing or cloud, we have to make sure people are trained. Imagine having an airplane and not knowing how to fly it. So at the architecture level, people like me always incorporate creation of training plans and a training budget and all kinds of things when it comes to rolling out an architecture. So we will have to train the people to use it. First, we need to get the stakeholder support in order to get people to use whatever the change is in the first place. We need their buy-in. And if we train people, the people can use the systems more efficiently, which can enhance their productivity, which means they can work better for the organization. If we have a system and we don't teach people how to use it, they're going to be afraid to use it, which means they may not actually use it as well. But the more comfortable people are, the more likely they're willing to use it. Now, if we have better staff, Our well-trained teams can innovate faster, giving us more value from the cloud and every other infrastructure investment we have. Our costs go down when people are trained, because imagine we've got someone that knows what to do and they do their job versus someone that doesn't know and they do 15 minutes worth of work and they cause us to have to do 10 hours of troubleshooting because they don't know what they're doing. Now, when you train your people, they typically get happy. They want to stay longer. So it's typically going to help accelerate everything by making sure your staff is well trained. Now, what kind of training resources? Well, there are certifications, and they will teach you a little bit, but typically certifications are the name of something and how to go configure it. I've tried to go a little deeper than that here, but that's the basis of a certification. Now, that's why we have things like our Cloud Architect program, which is a good 1,000 hours of training and create cloud architects that are all the skills to do the job, which is different than a certification course, which is the name of something and how to configure it. Architects we don't really configure things in our job anyway. So certifications can build your portfolio and teach you some of these things. And the certifications are great for the admins on your team that are basically clicking things and doing things, because that's what certification courses are. They're predominantly admin level. Now, there are organizations like ours that train people for cloud computing, and that's a way to really make sure that your people really know what they're doing as well. There's lots of vendor documentation, and you should always read it and provide training resources. There's lots of good books, and you should always get there. And obviously, the type of training that you actually need. So if you actually get, you're in a larger account, you'll get a technical account manager and their support, and they will often provide resources and learning plans and recommend specific resources for you as you have bigger levels of support. Because when you have better levels of support, the support providers actually realize that the better trained you are, the less support tickets you are, and the happier you are. So we have to do training. If we don't train our people, they'll make mistakes, and that can risk the entire organization. And we need to make sure there is continuous learning. Can't become an expert overnight, but over time and lots of learning, you can be. Now, you need to have the right practical experience. If I'm training an architect, for example, like a cloud architect, they're not going to be coding or configuring. That's not relevant experience for them. But giving a presentation, building a business case, responding to an RFI, RFP would be. Leading a architecture team. Creation of architectural training would actually be. Creation of thought leadership document would be. At the same time, designing networking and security and IAM and storage. And that is a cloud architect thing. By comparison, if I had a cloud engineer, not an architect, that cloud engineer needs to be able to administer systems. And that means they need to know how to use the systems. They typically need good Linux and good Windows system knowledge, typically good scripting knowledge in Python, for example, Bash shell scripting, Windows PowerShell scripting, and typically infrastructure as code. So you can see you've got an architect that's got one set of skills and a cloud engineer that's got a completely different set of skills, and you need the right skills for your job. And hands-on can be different. Hands-on for an architect might be giving a presentation. Hands-on for a DevOps engineer might be creating a Terraform script. Now, whatever we want to do, we want to constantly enable continuous learning. Now, we also understand we do have good support operations, for example, and Google will have various support operations based upon an organization's scale, size, and budget. We have role-based support, which is typically cost-effective for a small organization. We have premium support, which is going to be comprehensive support that's aimed at enterprises. And they're typically spending millions of dollars and are going to need real heavy-duty support services. And when we think about it, we need to think about support availability. And role-based support and premium support differ. So with role-based support, we might get 24-hour-a-day coverage 5 days a week. For with premium support, it could be 24/7. Now, these things change over time, so keep that in the back of your mind. I would check prior to the exam because they always change if you take this course 6 months from now. And response time's also different. So if you're a high-priority ticket, you get faster response times, for example. But your support offering will also determine how fast people get back to you. No, there are differences in the support method based upon the support service you have, like a phone versus chat support. And how your things will be escalated internally to other people and more significant resources inside of support will be different based upon what you have. So escalation process is a little different. Premium support gives you much more. Premium support gives you a technical account manager, for example. They'll be assigned to your premium support customers. They'll act as a dedicated resource to help align your organization's strategic needs and technical goals or tactical goals. There'll be a bridge between the organization's support and Google Cloud. So you've got someone you can call to really escalate things that's always going to be looking out for you. And typically when you're dealing with a big organization, they're going to need some previous level of support. Okay, everyone, that was our last session for the day. I'll check and see if anybody have any questions. I know I've enjoyed the last 9 days with you. Maybe tell me where you're at in the world. I always like knowing. I know Team Escalated is in South Africa. Polar Techie, thank you so much. I'm so happy to hear that. We really want to try. Team Escalate, I know you're there in South Africa. Thank you for joining us. I know it's getting around 10, 11 o'clock at night. So thank you for joining us. We're happy to have you here. Always happy to have you here. Jacques, it was so nice to meet you today as well. Mike, Leo, and Chris, thank you for providing this boot camp. It's very important. That's exactly our goal, is to help out. Lonzo, also from our team, kind of helped out with this. I think Chow helped him a little bit. So a lot of people at our team really worked to put these together, and I'm so happy everybody's learned a lot so far. Adrian, it's always wonderful to see you. I know where you're in Arizona, and it's always good to see you, and thank you so much. Little Rock, Arkansas. I have to get out there. Plus, I have to get to Mississippi because I saw the show called The Ozarks and it looked great. And I've been like all over the world except for that part of the world. Colorado, I used to go out there and consult with IBM in Boulder all the time. It was an extra good workout because if you were going to swim, the air was a little thinner, so it was a little harder. I always loved that. Sarah V in Canada, love that. Adrian, thank you so much. It's really so wonderful sending you. So go back, watch this playlist again. Toronto, Canada. You know what, Cedric? I spent a lot of time in Toronto and Mississauga. It was really quite lovely. Did a lot of work out there, actually. It was kind of like being in New York City, but it was really clean. It was kind of nice. And I worked in New York City for a little while, too. Very friendly compared to New York City, too. But although I had a lot of fun in New York City and lived there for a while. So thank you all for joining us. If you're curious about how to become an architect or skills that you need, join us in a free weekly architecture webinar. We're going to be there. We release a video to help you in your architecture career almost every day. Typically, we do a cloud architect, an enterprise architect, a security architect, often an AI architect, and or other professional developments. So come hopefully watch them, subscribe to the channel, go get them. Next week, we'll do a free webinar on how to design a multi-cloud architecture to keep stuff up when things go down, because things just go down. And usually on Wednesdays, we're here for career questions. So thank you all. Maybe give me a hashtag Google Professional Cloud Architect. Maybe give this video a like. Maybe subscribe to our channel. And please tell others so they can take advantage of this free training we put together. Take care, everyone. Hope you enjoyed this Google Professional Cloud Architect Certification Bootcamp from Go Cloud Careers. This is Mike Gibbs signing off for now, and I will see you soon. Take care.